NTD, TBC. Go ahead, sir. Okay, the shuttle range safety system are powered down, and range safety SRS vehicle power is off. ETR carrier no longer required. Copy.
NTD SRO on OIS 212.
PVD OTC 212.
This PVD. Yes, sir. You want to go ahead and pick up on step 80, increasing your payload bay flow rate.
Put in work now. NTD PTC.
This is Shuttle Launch Control. We have just passed the point where we were 1 minute away from the usable launch window. Of course, we knew immediately at the point that we scrubbed at 31 seconds that we would not be able to recycle in time.
Got it, sir. I copy. Thank you.
At the present time, we are still standing by to hear additional information about what actually happened. We know that the report was that the recirculation pumps, which are used to keep the engines in the proper condition prior to start, was not functioning properly in the case of engine number 1. However, it may be, the problem may not be related to the engine at all, but to the ground power source or to something in the orbiter. At this point, there really is no way of saying that. As we go through the recycle, and the first order of business with the launch team is to make sure that everything is safe, to get the crew out of the orbiter and to get them back to the crew quarters out of their suits, and then they will have lunch. The windows for launch continue to get larger as we go through the window. The opening of the launch window tomorrow, instead of being at 2:24, would be at 2:18, and then on Sunday would be at 2:13. On May 1st, it would be 2:07.
NTD, PTC.
And the duration of the window would go from 23 minutes today to 30 minutes tomorrow to 36 minutes, then 43, because as it opens earlier, the amount of time available before sunset over at the transoceanic abort site increasing. Standing by as the launch team continues with the recycle procedures.
Normal command channel.
This will result in a recycle back to the T-minus 20-minute point, and at that point then we will be beginning the egress procedures with the crew. This is Shuttle Launch Control.
TBC, NTD. TBC. Okay, can you verify EP locks and stable drain? Stand by. Okay. NTD, TBC. Go ahead. We can verify we're in stable drain. Okay, and ET LH2 in terminal count safety? That's correct. It's TBC. Okay, and ET recycle is complete? That's correct. Okay. OTC, NTD.
Go ahead.
Will you want to do any cockpit securing?
That's affirmative.
Okay, I'd like to perform your cockpit securing sequence 19 at this time.
Copy that.
NTD, PTC. Go ahead, PTC. Any indication when Milo is going to start reducing their power? We're taking a lot of telemetry hits at this time. We're afraid to loosen a spacecraft string.
Yeah, OTC, Milo can take that down at this time.
Go ahead, TBC. Okay, stand by. OTC, CGNC.
Go ahead.
Step 68 through 72 complete. 73 through 77 not performed. 78 not performed.
Okay, copy that. OTC CPVD. Go ahead, PVD.
Sequence 18, step 81 is not performed. 82 was performed. The flow rate is 230 pounds per minute. And step 84 is not performed.
Copy that. PLT, OTC.
OTC, PLT, go.
Sir, I'd like to go ahead while they're on their way out there and try to get some of our cockpit securing done.
Standing by.
Okay, panel 08.
Go ahead.
Left on tank isolation. A switch, GPC. Talkback, open.
That's complete.
And B switch, GPC. Talkback, open.
Also complete.
Copy. Left ohms cross feed. A switch, GPC. Talkback, closed.
Complete.
And B switch, GPC. And give me a talkback position, please.
D switch is GPC, talkback is closed.
Copy. Right ohms, tank isolation. A and B switches, GPC, talkback, open.
Complete.
Copy. Right ohms cross feed. A and B switches, GPC, talkback, closed.
Complete.
Forward RCS, helium press. A and B switches, GPC, talkback, open.
That's complete.
Copy. Tank isolation, 1, 2 switch, and 3, 4, and 5 switch, GPC, talkback, open.
Complete.
Manifold isolation, all 5 switches, GPC, talkbacks, all open.
All manifold ISO GPC, talkbacks open. Complete.
Copy that. OVCC OTC net 105. Yes, sir. You can proceed to pad for flight crew egress operations. Portable O2 meter is required to check O2 contents in white room. Thank you. Okay, and PLT OTC.
Go ahead.
On panel 07.
Go ahead.
Aft left RCS, helium press, A and B switches GPC, talkbacks open.
Complete.
Standby 1 PLT. Go ahead, OVCC. Copy that. Okay, standby. You should get cut loose momentarily. PLT, OTC.
OTC, PLT, go.
Okay, sir. Manifold isolation. 5 switches, GPC. All 5 talkbacks open.
Okay, all left RCS manifold ISOs GPC open. Okay, that's complete.
Copy. Aft right RCS, helium press, A and B switches to GPC and talkbacks open.
That's complete.
Copy. Manifold isolation, 5 switches, GPC, 5 talkbacks open.
That's complete.
Okay, copy that. And on 014.
We'll try.
Okay, on row F, RJDA 1A, L2R2 manifold, driver and logic switch to off.
Okay, 1A driver and logics are off.
Copy that. 2A, driver and logics off.
That's complete. 2A driver and logics are off.
Okay, and RJDF 1B, F1 manifold, driver, and logic switches to off.
That's complete.
And left ohms engine valve switch off.
Left ohms engine valve is off.
Copy. 015.
Go ahead.
Row F.
We're ready.
RJDA 1B, driver switch off. And logic switch off.
Complete.
RJDF 1A,
Go ahead.
driver off and logic off.
Drive and logic's off.
Copy. 016.
Okay, it's complete.
Okay. Panel 016.
Go ahead, sir.
Okay. RJDA 2B, driver and logic off.
Complete.
And RJDF 2A, driver and logic switches off.
Complete.
RJDF 2B, driver and logic switches off.
Complete.
And RJD manifold, driver switch off. Verify.
That's verified, sir.
Copy. Right ohms engine valve switch off.
Right ohms engine valve off.
Copy.
Complete.
Thank you. CDR OTC.
CDR, go.
Yes, sir, on panel C3.
Okay.
Ohms engine, left and right switches off.
That's complete.
Copy. COOS OTC. COOS OTC 212.
Double S, go ahead.
Yes, sir. Step 33 in sequence 19. You verify.
That is verified.
Thank you.
CMPS.
PLT OTC.
OTC, PLT, go.
Yes, sir. Panel R1.
Go ahead.
Power distribution and central bus source. Fuel cell 1, 2, and 3 switches off.
That's verified.
Copy. Q, ISL OTC. CISL OTC.
This is ISL, go ahead.
Yeah, 19035.
That's already been performed.
Okay, so we should not perform that, not perform ISL the next 5 steps, or 6 steps.
That's correct.
Thank you. And CDR OTC.
CDR, go.
Yes, sir. Panel 07.
Okay.
TACAN 1, 2, and 3. Mode switches off.
This is Shuttle Launch Control, the launch team continuing to go through the recycling process here, getting everything into the condition where the crew can leave the orbiter and return to the crew quarters. At this point, no announcement has been made as to when we are going to recycle, whether that would be tomorrow, the next day, or even further. A meeting has been scheduled for 3:30 in which all of the data will be assessed by the managers and the engineers involved in the process. Following that meeting, there will be an announcement as to what the outcome of it was, what sort of tests might be necessary, and when we will try again. At the present time, the problem involves engine number 1 and the recirculation pump, which is used for moving hydrogen and oxygen around in the engine prior to the actual engine start. That is powered by a ground system. However, at this point, there's no indication as to exactly where the fault lay. A meeting of engineers and managers will occur at 3:30. Following that, there should be an announcement as to the next proposed launch date and what the plan is for doing the troubleshooting, fixing whatever the problem is, and then proceeding on. The flight crew is in the process of continuing their preparations in the cabin and to leave the cabin at the appropriate time. We'll be standing by here for the egress of the flight crew, and then standing by for an announcement following the 3:30 meeting as to what the plan for recovery and launch is.
Since we lost 3 out of 6, do we have...
There were a number of issues that were worked as we went through the countdown today, and in the end, all of them were cleared up, and something that had not been expected caught the team by surprise and resulted in the countdown being terminated. The Magellan spacecraft had a problem when its receivers were saturated by the Mila tracking station going to full power. Once that was understood, the Magellan was cleared for launch. It appeared that we might have a weather problem. The crosswinds at the shuttle landing facility were very marginal and probably in violation earlier in the day. But as expected and forecast by the weather forecasters, the wind shifted around from the southwest to the southeast, and at the time of the proposed launch, conditions were satisfactory. There were some marginal conditions overseas. However, it turned out that everything was go at the time of launch there also. Almost at the last minute, there was a problem with the range computer. That was brought back up online with only a few minutes lost and plenty of time to launch. And in the end, at T-minus 31 seconds, the clock was stopped when a problem with the recirculation of hydrogen and oxygen through engine number 1 ran into trouble, and at this point there has not been a determination of exactly what caused that problem. An announcement as to the next launch attempt and the troubleshooting plan will be made following a meeting at 3:30 this afternoon. This is Shuttle Launch Control.
OTC, OVCC.
Go ahead, OVCC.
Okay, you can see we're back in the white room.
Copy that. Okay, and OVCC, configure white room for orbiter egress per ops. Support setup 19.
We copy, that's in work, sir.
Okay. SOTC on 212, all over the personnel do have a go to perform subsystem recycle operations per sequence 19, section 3.
OTC, say 20.
Go ahead.
Okay, we can verify hydraulic recycle complete steps 106 and 107.
Copy.
OTC, OVCC.
Go ahead.
This is Shuttle Launch Control. The launch team still in the recycle mode, and at this point the closeout crew has returned to the pad and is in the process of opening the access hatch on the orbiter for the crew to egress. At this point, the Launch Director Bob Seek has announced that he wants to preserve the option for possibly trying for a launch attempt tomorrow for another several hours until there can be an assessment of exactly what needs to be done. The original meeting to complete that assessment and talk to managers has been moved from 3:30 to 4 now, and so a final decision on exactly what the problem is and when next launch attempt will probably be 2 or 3 hours from now at the earliest. At the present time, we'll be standing by to report on any new information which comes out, but we don't expect that any information on the problem which stopped this countdown will be coming out until after the 4 o'clock meeting. The closeout crew in the White Room opening the door, they have to remove the insulation plugs and then they open the locking devices in order to allow an orderly egress of the crew. That crew will be taken back to the crew quarters as soon as they leave the pad, and it'll be time for lunch for them.
Go ahead.
2 meter look.
Looks good there, sir.
Okay.
Some of the panels on the doors off now, and just about time, in just another couple of minutes, the hatch will be open. Everything proceeding smoothly, safely as we recycle the launch vehicle. This is Shuttle Launch Control.
CGSS OTC 212.
CGSS.
Okay, sir. Sequence 19, step 4 and 5 will be not performed. Is that correct?
Yes, that is correct.
Thank you.
And do we have a go to perform step 57?
OTC NPD. Yes, sir. You have a go to do that CGSS, but they also need you over on channel 123.
All right, copy.
CDR OTC, looks like your ride back has arrived at the pad. The Astroman's at the base of the FSS.
Okay, thank you very much.
You see CPVD?
Go ahead, PVD.
Do you want leeward vent doors 1 and 2 open?
Repeat, PVD.
Should we open leeward
This is
vent doors
Shuttle
1 and
Launch
2?
Control. The crew beginning their egress procedures, leaving the orbiter.
Yes, sir.
The closeout crew assisting them in that process. They have already removed their helmets, which they had on, locked, and the visors in place earlier. Dr. Norm Thaggard getting out.
OTC CPVD.
Go ahead.
Okay, vent doors 1 and 2 right-hand side. Leeward vent doors are open at this time. That'll be step 18-0098.
Copy that.
This is Shuttle Launch Control. The closeout crew putting on the special booties and leg protectors. The primary reason for that is not really for protecting the legs. It's for making it possible to keep the cabin as clean as it possibly can. Mission Specialist Mary Cleve and the rest of the crew coming towards the elevator, which will take them back down to the pad surface.
The LH2 tank back to flight pressure.
Yeah, I understand. Okay. Yes.
This is Shuttle Launch Control. People who are able to watch the NASA Select pictures of the egress procedures can see the placing of platforms in the orbiter. It's really very awkward getting both in and out of the orbiter. The orbiter, of course, is sitting at a vertical position rather than a horizontal position. So the crew has to actually lie in their seats on their backs when they're in there, and then also they have to climb up through portions of the orbiter on the walls rather than on the nominal floor. Of course, in space that doesn't matter because no way is up or every way is up depending on how you look at it. The egress of the crew in the process of taking place. Once the crew is out, there will have to be a reconfiguration of the cabin once again in preparation for picking up the countdown on whichever day it's decided that will happen. At the present time, we are protecting the possibility through the recycle methods of trying for a launch tomorrow. However, that will not be firmly decided until after a meeting which is presently scheduled to start at 4 o'clock between the engineers, managers, and mission management specialists. The window for tomorrow opens at 2:18 p.m. Eastern Daylight Time, and then would last for 30 minutes, closing at 2:48. It continually gets longer as we go through the month until finally it is a 2-hour window beginning about May 12th. We don't expect that that's going to be necessary, but at this point the team is still in the process of assessing what happened with the recirculation system, and they will be reporting their findings as soon as those are available. This is Shuttle Launch Control.
OTC, CGSS, sound suppression system recycle is complete.
Copy, GSS.
59 was performed. 60 was performed. 61 was a not performed. 62 was a not performed.
Copy.
OTC, ask Patty Rio, down one.
I read you loud and clear. Ask down me.
Loud and clear. Okay, and OTC CDR with the Aspon comm. I'm going off a loop. I'll be beginning my egress.
I copy that, sir.
Good try. We'll come back. See you.
Okay.
See you in a couple days.
Roger that.
OTC, OBCC.
Go ahead.
Okay, your hardline oxygen system is in place.
Copy that.
We're getting there.
OTC, CCL 212. Go ahead. Yeah, we've completed part of our ECLSS recycle. Cabin bending was not required for step 77, which gave us an op form on 78, 79, and 80. However, we would like to work step 81.
This is Shuttle Launch Control. Commander Dave Walker and pilot Ron Graby should be exiting from the orbiter any minute now. They have gone off of their headsets and their communications with the Launch Control Center and the flight director in Houston. The three mission specialists, Mary Cleve, Norm Thagard, and Mike Lee, already out of the orbiter.
Copy, we've got an STS standby.
Okay. Supply water.
Stand by a second there. We're still got crew coming out.
Okay, let me know when you get a chance.
I got it.
No hurry.
Yeah, OTC ASP, I'm looking at ML26 Charlie. Both valves are down.
Yeah, we need them in the...
And Commander Dave Walker out of the orbiter now.
I'll do it on your call.
Okay, tank A, vent valve. Take it to the thrust position. That's up.
Okay, ML26 Charlie. We're talking about... you sure you got the right panel there? We've got the GN2 tank vent valve, and we've got the tank A water tank A supply valve.
Right, that's it. Both of those need to go in the up position, thrust and open.
All right.
Commander Dave Walker coming out and getting ready to go into the elevator and join the rest of the crew down at the Astro van. Here comes some of the closeout crew as well.
Complete ECLSS recycle. Copy, ECL.
The Astro van at the pad surface, standing by to take the crew back to the crew quarters, where the plan is that they'll have lunch and then relax until they find out what's going to happen next. We'll be standing by also. We're concluding commentary at this time. At this point, we know that there was a problem with the recirculation pump system on engine number 1. However, whether it's really related to the pump, whether it's a ground electrical power source, whether it's a controller, whether it's a sensor, is really not known. The management team, the engineers, and the test conductors going into a meeting to discuss that. We're preserving the possibility of launching tomorrow. However, that has not been decided, and there will not be a decision until after the meeting, at which time it will be announced in the usual way. This is Shuttle Launch Control.
This is Shuttle Launch Control at T-minus 4 hours, 13 minutes and counting. Tanking of propellants aboard the Space Shuttle external tank continues to go smoothly. That operation began at about 10 after 5 this morning, about 20 minutes ahead of schedule. Currently we stand at about 280,000 gallons of liquid hydrogen. That's about 70% of the load, and about 75,000 gallons of liquid oxygen, which is about 50% of the load. The liquid oxygen is much heavier, takes more time to load on board, even though there is less of it. So liquid oxygen tanking will take about an additional hour beyond what the liquid hydrogen tanking will take. In about another half hour, the Magellan test conductor will begin to poll his systems test team to evaluate the health of Magellan. Also underway at this time is the Mila antenna line, the alignment of the tracking station to the launch pad. The countdown in the final minutes has been adjusted somewhat since the problem in the last few minutes of the countdown with Magellan, where the Magellan receiver locked up. So in the last 11 minutes, the Mila high power will be switched on instead of at launch minus 90 minutes. So that means low power will continue for much longer, and therefore the chance of a Magellan receiver lockup is greatly diminished. High power will go on at launch minus 11 minutes, and also we will be using an alternate frequency on board the orbiter, so there is less chance that the Mila receiver will recognize what transmissions are coming from the tracking station that are intended for the orbiter. Magellan continues to have a trickle charge on its batteries. In the payload bay, Magellan and the inertial upper stage were never powered down, and essentially they have been on standby. The test team has been monitoring the health and status of Magellan. The inertial upper stage has been in hot standby, and a trickle charge has remained on Magellan's flight batteries. That trickle charge actually will continue all the way up until about 40 minutes before launch. At this time, the countdown continues to go smoothly. As of like the countdown last Friday, absolutely nothing is amiss, and we are pressing on toward a liftoff at 1:48 p.m. this afternoon. At T-minus 4 hours, 10 minutes, 10 seconds, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 58 minutes and counting. Loading of propellants aboard the external tank continues, being controlled from firing room 1 at the Launch Control Center on Complex 39. That operation continuing to go smoothly. We now have about 70% liquid hydrogen and about 80% liquid hydrogen and about 60% liquid oxygen. That activity will be continuing for about another half hour to 45 minutes. It will be completed slightly ahead of going into the built-in hold because we did pick up tanking about 20 minutes early this morning. It is raining at the launch pad currently. There are scattered showers in the vicinity. There are a number of showers west of the Space Center out over the St. John's and also downrange about 25 miles or so. None of these clouds are charged at this time. They don't present any lightning potential, including the rain shower that's over the pad. And as a matter of fact, the rain shower is good for the ice team because it diminishes the chance of ice buildup. The warm rain will be melting any ice which may be forming around the external tank or any of the lines, so that much like frost that builds up on the windshield of your car, the easiest way to get rid of that is to simply throw some warm water on it, and that's what the effect of this warm rain will have on the external tank in any areas where ice may be building up. The hold that we'll be entering at about 8:28 this morning is 2 hours in duration. That's a standard built-in hold, and 2 holds remain beyond that time. The 10-minute hold at launch minus 20 minutes, and another 10-minute built-in hold at T-9. This hold has been adjusted from Friday's count to a 10-minute hold from 40 minutes because now that we have better than an hour to launch, the additional time is not considered necessary. The flight crew remains asleep and will be awakened about 10 minutes to 9 this morning, after which they will have breakfast, don their flight crew equipment, their pressure suits, and they'll be getting a complete briefing on the weather and on how the countdown has been going and on the status of Magellan. Again, the countdown continues to go smoothly here from firing room 1. No problems in discussion, so most of the technical channels on the consoles are quiet. At T-minus 3 hours, 55 minutes, 20 seconds, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 43 minutes and counting. The countdown for the launch of the Space Shuttle Atlantis with the Magellan spacecraft for Venus continues to go smoothly this morning. No problems are in work at this time, and the loading of the external tank with the 550,000 gallons of propellant is nearing completion. At this time, we stand at about 90% liquid oxygen and about 97% liquid hydrogen. We'll be going into stable replenish on the hydrogen shortly, and oxygen should be approaching replenish about 8 o'clock. Launch Director Bob Seek has given the go-ahead to begin mustering crews at the roadblock, the ice inspection team, the contingency fire and rescue team, and the astronaut closeout crew. Normally, we would send those teams into the pad when we enter the 3-hour built-in hold, which would be about 8:30 this morning. However, the propellant loading and the countdown had been running between 20 and 30 minutes ahead of schedule. So the decision is to press on and send the teams in and get some of that work underway with the ice inspection team and the closeout crew. Also underway at this time is the Mila antenna alignment. The tracking station at Kennedy Space Center continues to set up on the Space Shuttle out at the launch pad and verify the signals that it is getting back from the orbiter and that it will be sending proper commands. Scattered rain showers continue in the Cape Canaveral vicinity. These are expected to dissipate somewhere around 9 o'clock this morning as the sun continues to rise. At T-minus 3 hours, 41 minutes and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 28 minutes and counting. Loading of the external tank with propellants is nearing completion. The liquid hydrogen operation is now completed. Liquid hydrogen now in stable replenish. Liquid oxygen now stands at 95%. We're running about 25 minutes ahead of the countdown bar chart, and Launch Director Bob Seek has directed the closeout crew and the ice inspection team to assemble at the roadblock to prepare to enter ahead of entering the 3-hour built-in hole, which is scheduled to begin at 8:28. Associate Administrator for Spaceflight, Admiral Richard Truly, has joined Launch Director Bob Seek here in the firing room. Recapping where we are and looking at the overnight activities. The Magellan and Inertial Upper Stage Payload Test Team had a call to stations last night at about 10:45 to begin reconfiguring the payload for launch. The guidance system aboard the inertial measurement unit was aligned beginning at about 12:30, and that operation was complete at about 2:45. The mission management team, headed by Bob Crippen, had a tag up at about 4:30 this morning to evaluate where things were in the countdown and to look at any technical issues which may be in work, and there essentially were none. So a go for tanking was given at about 5 o'clock, and tanking actually commenced at about 5:10, about 20 minutes ahead of schedule, and we had been running ahead of the countdown bar chart since that time. The Eastern Test Range has completed their range safety command checks. The inertial measurement units, the guidance system on board the flight deck of the orbiter, has received its pre-flight calibration. The Mila tracking station has been aligning its antenna with the space shuttle on the launch pad and verifying the data going to the shuttle and the data that it is receiving back. Magellan is also in a go configuration. They continue a trickle charge on the battery that will continue until about 40 minutes before launch. About 2 hours ago, they polled their systems engineers on the status of Magellan on pressures, temperatures, voltages. All systems were go, and they will be doing another poll in about another half hour. Weather-wise, the forecast continues to appear favorable for later this afternoon. The forecast is essentially unchanged from what it was yesterday. At liftoff time, we are expecting 3,500 scattered, 25,000 scattered, visibility 7, temperature 84 degrees, winds east-southeasterly at 10, gusting to 15, a 40% chance of violating the launch weather rules at liftoff time at 1:48. At this time, scattered rain showers continue in the Cape Canaveral vicinity. There is actually a line of showers that extends from just east of Orlando out over the range for about 65 miles. These are just rain showers, no electrical potential, and there has been some scattered rain around the launch pad from time to time. This does not hinder tanking at all, and in fact will aid the ice inspection team when they go in, because the warm rain will tend to wash away any ice which may have formed up on any of the lines or around the tank. The weather balloon data has just come in from the balloon launched about 2 hours ago, and the upper air winds right now continue to appear favorable. That balloon run is essentially unchanged from the one that was done around midnight, and at the moment we do not expect to have to make any change in the onboard computer programs for launch. Also, weather at the TAL sites appears favorable. The primary site is Ben Guerir, and the weather forecast there is also acceptable. The astronauts continue to be asleep. They will be awakened about 10 minutes to 9 this morning, after which they will suit up, have breakfast, and then be given a briefing on the status of the countdown and on the weather for launch time before they begin suiting up. At this time, the countdown continues to go smoothly. No technical issues being worked. At T-minus 3 hours, 22 minutes, 50 seconds and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 13 minutes and counting. Associate Administrator for Spaceflight, Admiral Richard Truly, conferring with the Chairman of the Mission Management Team, Bob Crippen, here in the firing room. Also here in firing room 1 with Launch Director Bob Seek is Kennedy Space Center Director General Forrest McCartney. We're about 8 minutes away from going into a planned 2-hour built-in hold. Events are running slightly ahead of schedule at this time. Loading of propellants aboard the external tank is essentially complete, and the NASA test director has cleared the ice inspection team to the pad to begin their operations to look for any ice buildup around the external tank and the orbiter. Also completed now are the alignments of the Mila tracking station. All good data now coming back from the orbiter. Magellan also continues to be in good health at this time. They continue to have a trickle charge on their batteries while they operate off orbiter power. We're in the middle of a shift change here in the firing room as the team that worked overnight prepares to leave, and the team that will support the launch is coming on at the engineering consoles. There is a handoff period of about a half hour where the two teams sit together to go over how the systems are performing, go over what problems which may be in work, if any, before the second team goes off. This is a fairly quiet time in the countdown. Control switching is in effect, which means that there is no console operation. None of the technicians or engineers are allowed to touch the keyboards on their consoles, so that nothing can be inadvertently changed out at the launch pad while the closeout crew and the ice inspection team are in position doing their tasks. While we are running somewhat ahead in the countdown, preparations by about a quarter of an hour or so, there are no plans to awaken the crew early, and they are still scheduled for awakening at about 8:53 this morning. As predicted, the rain showers in the vicinity are gradually beginning to dissipate. That scheduled estimate for dissipation sometime around 9 a.m., and this has not had any impact on the fueling operations, which have been underway since about 10 minutes after 5 this morning. At T-minus 3 hours, 10 minutes and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours, 30 seconds and counting. We're preparing now to go into the 2-hour built-in hold. During that period, the ice inspection team will be going through their operations to look for ice around the external tank and the orbiter. Also, the closeout crew will be going to the white room at the launch pad to support the astronauts. Going into the hold now in 3, 2, 1, T-minus 3 hours and holding for 2 hours. We'll pick up the countdown at 10:28 again this morning. The ice inspection team has reported that they are now on the pad surface and proceeding to the mobile launcher platform to begin their operations. Currently in the firing room, it continues to be quiet, no significant issues being worked. KSC Director General Forrest McCartney is in consultation with Admiral Truly. Launch Director Bob Seek is preparing for a weather briefing, which he will be receiving shortly. And looking at the weather for launch time, there really is no change, at least at this point. We're still looking for scattered clouds at 3,500 and 27,000 feet, visibility of 7 miles, east-southeasterly winds 10 to 15 knots, temperature of 84 degrees, and a 40% chance of violating the launch weather criteria. TAL sites look good. The Ben Guerir site will be primary, and their weather is acceptable. Flight crew on schedule to be awakened about 8:53. Preparations for the launch continue to run about a quarter of an hour ahead of the bar chart, principally because there have been no problems in work, and we were able to pick up tanking just slightly early this morning at about 5:10 instead of 5:28. At T-minus 3 hours and holding, this is shuttle launch control.
This is shuttle launch control at T-minus 3 hours and holding. We're just 15 minutes into this two-hour build-in hold. There'll be 2 additional build-in holds, both 10 minutes in duration at T-minus 20 minutes and T-minus 9 minutes. Both the ICE team and the closeout crew are in the pad area now. The ICE team is on the 0 level, or the deck of the mobile launch platform, and there they will inspect the tank's aft dome and the shuttle engines. Their next step will be at the 135-foot level, which will permit a good view down on the orbiter to external tank umbilicals, and then on to the 195-foot level, which is the point where the crew access arm extends from the service tower over to the vehicle and affords a view of the orbiter's forward attach point to the external tank. From there, they'll go to the 215-foot level, which corresponds to the very tip of the external tank. From there, they can see how effective the beanie cap, or the gaseous oxygen vent hood, is at collecting the gaseous oxygen vapors and preventing them from forming ice on top of the external tank. Once they've completed that walk down, they'll go back and stop once again at the 0 level of the mobile launch platform before concluding their inspection. In addition to looking at ice on any of the attachments or any of the various parts of the main engine system, they're also looking for any loose debris which might be on the platform, tools, stanchions, anything that could be picked up and thrown about by the force of launch. They, of course, want to avoid any possibility of something hitting either the orbiter or any part of the vehicle at the time of liftoff. Everything has been going very smoothly in our countdown. The weather people saying still that there is a 60% chance that everything will be satisfactory for launch on time this afternoon at 1:48. The countdown clock at T-minus 3 hours and holding. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. We're just 25 minutes into that 2-hour build-in hold. And NASA Test Director Ron Phelps has been in contact now with personnel over in the astronaut quarters and has given them permission to wake the flight crew in preparation for this afternoon's launch of STS-30. Crew wake-up is one of the major milestones in the countdown, and it signifies the launch team's confidence that the vehicle is ready for launch. Normally, if a problem existed, then the crew would be allowed to continue sleeping, because flight directors have determined over the years that they don't want the astronauts to have too long a workday from wake up until start of their first sleep period. Everything appears to be going very well in the countdown. The ICE team still taking a look at the area around the main propulsion system on the aft end of the orbiter, and they take a look at it both with optical instruments, a telescope, binoculars, and also with infrared detection systems to take a look at what the temperatures actually are, and in particular they're interested in any buildup of ice. The ice inspection team is dressed in non-static producing flame retardant coveralls and carry gas masks for emergency use. In addition to the ice team and the closeout team, there's also a rescue team on hand out there at the pad. The rescue team is located at one of the roadblocks leading into the area, but can arrive in just less than a minute. out near the bunker, there are two M113 armored personnel carriers, which would be used if a fast escape from the pad by workers is necessary. They're stationed by the slide wire bunker and with their motors running, and there are two drivers there, and the drivers will remain there until the closeout crew and the ice team have left the pad. After that, one of the M113s will be left with the motor running in case there's any need for the crew, the astronaut crew, to leave the pad in a hurry. The countdown going very smoothly. We have approximately 1 hour, 32 minutes remaining in this build-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. We just have 1 hour and 20 minutes remaining in this build-in hold. Out on the pad, the ice team has completed their initial inspection on the top of the mobile launch platform and have just announced that they're going up to the 135-foot level. In the cabin, everything going smoothly as they prepare for the arrival of the crew. And over in the crew quarters, the crew getting close to the time when they will be having breakfast. That should occur in about 10-15 minutes from now. Once the crew has their traditional breakfast, then the commander and the pilot, Dave Walker and Ron Graby, will have a last-minute weather briefing from the Mission Control Center in Houston. In the meantime, the three mission specialists will put on their flight clothing and gear, and then when the weather briefing's over, the commander and pilot will put on theirs and prepare for the 9-mile trip to the pad. Other activities that are going on out here on the pad, the solid rocket booster engineers are just completing a torque test of the rate gyro assemblies on the solid rocket boosters. These gyros measure the rates of motion of the solid rocket boosters during flight. The weather is still forecast to be satisfactory for our launch this afternoon. Clouds should be scattered at 3,500 feet, scattered at 25,000 feet with visibility about 7 miles or more. The temperature should be 84 degrees and the winds about 10 from the east-southeast gusting to 15. At the present time, they're still forecasting a 40% chance of a rule violation, which means a better than 50% chance of not violating any of the constraints. Weather balloons are launched periodically throughout the countdown to determine how the winds are at the upper levels. Most of the balloons going up to 50,000 feet or more, and then that information being fed into the computer to analyze the various motions of the balloon as they move up through the atmosphere. This is used to decide what flight programs to use in the computers and how to fly so that you have the least amount of stress on the orbiter and the rest of the shuttle during the ascent out of the Earth's atmosphere. Everything going smoothly at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. During this next period of the build-in hold, the supply of drinking water must be monitored to ensure that there is enough room to accept water being made by the fuel cells during the next number of hours. If it is decided that not enough room exists, the water will be drained from the system to get to the proper level. During the T-minus 3 hour hold, they attempt to drain to just 5% fill of the 20-gallon tank, which is used to hold the fuel cells water byproduct. And the plan is to have 50% at T0. The launch control commit criteria limit is 83%. The way in which the amount of water is controlled during the balance of the countdown is by adjusting the amount of ground power that's being used by the orbiter as opposed to the amount of power which has to be produced by the fuel cells. The more fuel cells power is produced, the more water byproduct is produced as well. Up on the area where the orbiter access arm is, the ICE team up there with all of their various types of instruments taking a look at the orbiter to external tank connections to ensure that there's no buildup of ice in that area. The main purpose of the insulation on the outside of the external tank and on the various attachments which connect the tank to the solid rocket boosters and to the orbiter is to prevent the surfaces from becoming so cold that water vapor from the air can condense out and cause a buildup of ice. The guidance, navigation, and control engineer in the firing room has reported that the pre-flight calibration performed on the orbiter's inertial measurement units was satisfactory, and another calibration will not be needed. This would have been the time to perform that task if it were needed. The inertial measurement units will begin their pre-flight alignment at T-minus 1 hour or 110 minutes before liftoff. The Magellan spacecraft, which is the primary mission of STS-30, has been in a very quiet mode ever since the scrub last Friday. Actually, very little had to be done to the spacecraft. Just simply some trickle charging of the batteries. We have a very proud crew of people from the Jet Propulsion Laboratory, from Martin Marietta, where it was built, and the other people who have been involved with this. This is the first launch, of course, of an interplanetary probe or orbiter by the United States for approximately 11 years. We're standing by to go to the crew quarters at the O&C building for the crew breakfast. They've completed dressing and cleaning up for their first day in orbit. When we join the crew, you'll see them sitting at a breakfast table. Actually, you won't see the type of food which they'll be choosing for this morning. In the center, of course, Commander Dave Walker, going over to the end from left to right, is Mission Specialist Norm Thagard, Pilot Ron Graby, Commander Dave Walker, Mission Specialist Mary Cleve, and the rookie of the crew, Mission Specialist Mark Lee. Mark Lee is just 36-year-old, and he's a major in the U.S. Air Force. Mary Cleve has logged 165 hours in space. Norm Thagard has flown on STS-7 and STS-51B, which was a Space Lab mission. And, of course, Dave Walker, who is 44, flew as pilot on the 51A mission aboard Discovery in November of '84. In front of the crew, you could see on the table a cake decorated with the official STS-30 crew patch. And that cake will be frozen. They won't eat it for breakfast. It'll be frozen for the celebration when they return from space and their mission. Their patch depicts the joining of NASA's manned and unmanned space programs. The sun and inner planets of our solar system are shown with a curve connecting Earth and Venus and symbolizing the shuttle orbit and the spacecraft trajectory toward Venus and its subsequent orbit around our sister planet. Venus, of course, has always been of particular interest to scientists here on Earth. It's the really sister planet when you take a look at all of the planets in the solar system. It comes closest in size and mass and distance from the sun, but it's certainly very unhospitable to the type of human life which has evolved here on Earth. The countdown going well, periodic updates of the weather whenever possible. The weather appears to be the only real problem that they're looking at today, and it's simply a matter of whether the sea breezes will be able to blow the clouds and any rain showers away from the Cape area as expected. There's about a 60% chance that that is going to happen and that we will be go at 1:48. The countdown clock at T-minus 3 hours and holding. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. At the present time, for those of you who are watching NASA Select on the satellite, we are switching our transmission place from the Kennedy Space Center, where we've been carrying scenes of the preparations for the STS-30 launch, to the Johnson Space Center, where it will be reconfigured for the crew weather briefing, which will occur following the crew breakfast. This is a time for the commander, Dave Walker, and the pilot, Ron Graby, to get an update on the weather conditions all around the world, which affect the launch here. The primary transoceanic abort site for this afternoon's launch is Ben Guerir, Morocco, with the weather alternate in Morón, Spain. However, it's also possible under some conditions to use Yumdum Airport in the Gambia near Banjul. We've just had a weather update on the weather here at the Kennedy Space Center. It's expected that the clouds will be scattered, variable to broken for the balance of the morning and into early afternoon. There is some possibility of building rain showers. However, it is still expected that the sea breeze will be moving the clouds north, so that at the time of launch, 1:48, that we're hoping we will just have scattered clouds in the area and no problem as far as rain showers or any thunderstorms are concerned. There was some indication that we might have a slight increase in the surface winds. The direction of those surface winds would be the critical problem. We cannot have more than a 12-knot crosswind out at the shuttle landing facility for a return to launch site abort. So if they turn enough so that they're at more of a headwind, then that would not be a problem. At the present time, the return to launch site abort runway is planned as 15. 15 basically means that the orbiter would be landing from just about 30 degrees off of north towards the 30 degrees off of south. 15 stands for 150 degrees, with 180 degrees being due south. The ICE team has announced that they have moved up to the 215-foot level. That's the top of the service platform out there at the launch site. And there they can take a look at the top of the external tank and see how effective the beanie cap is at preventing any of those vapors from seeping out and causing condensation and some ice buildup. Launch Director Bob Seek talking on the loop now, saying that he's quite optimistic that the the clouds and the showers in the area are moving out at the present time. He's saying that the local weather looks pretty good, and of course we are watching the weather at the transoceanic abort sites. Everything going smoothly. We have 51 minutes and 15 seconds remaining in this built-in hold at the T-minus 3-hour point. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. Just 45 minutes remaining in this built-in hold. We will have 2 additional 10-minute built-in holds at the T-minus 20-minute and the T-minus 9-minute point. The ICE team still on the 215-foot level, taking a look at every part of the shuttle that they can see. They're using a variety of equipment, including binoculars, a telescope, and special infrared scanners, which can be used to determine the skin temperature of the tank at any spot that they choose. A bucket of ice is used to calibrate that scanner in the same manner that TV people use white paper to color balance their TV cameras. We're standing by for the flight crew to complete their breakfast and then start the suit up for the 3 mission specialists and the weather briefing from Houston for the pilot and the commander. The breakdown of the payload weights for the Magellan spacecraft, which basically is very quiet throughout the countdown, is sort of interesting. In order to get the 7,383-pound Magellan spacecraft to Venus, approximately 33,000 more pounds of equipment and rocket power is needed. The Magellan IUS adapter, the IUS, the inertial upper stage, which will be used to power the Magellan out of Earth orbit onto the Venus trajectory, weighs 220 pounds. The inertial upper stage itself weighs 32,438 pounds. And the various equipment that's associated with it, which is used to raise the IUS and the Magellan and eject it very slowly from the payload bay using springs, weighs another 5,756 pounds. So altogether, the Magellan spacecraft and the equipment it needs on board the orbiter weighs 45,000 pounds, but only 7,300 of that is actually the Magellan spacecraft. And a large percentage of that is the solid rocket motor, which will be used to put it in orbit around Venus once it arrives. In the White Room on the 195-foot level out at the pad, the closeout team is in the process of completing their work to prepare the crew cabin for the arrival of the flight crew. That closeout crew is made up of Bruce Melnick, who is the astronaut support person. Number 1, I believe, is Paul Arnold, who is the closeout crew leader. Carl Bernhardt and Steve Crosby and Dwayne Waters are all Lockheed technicians. And there's a NASA quality control person, Jay Sullivan, who is also a member of that 6-person team. One of the checks during this particular period before we come out of the 3-hour built-in hold is with the spacecraft manager, and Magellan Project has just verified that it meets the launch commit criteria at this time. And of course, they're very anxious. They don't really mean Venus or bust. They're quite willing to have us hold the countdown if necessary and give them the best possible ride that's possible. But they have been working on this project since really in the early 1970s was when the project was conceived. It wasn't until we got into the 80s that we really started putting together the parts for it. And the Magellan spacecraft itself is somewhat of a patchwork of equipment and instruments that have come from other spacecraft in an effort to keep the price down. One of the main jobs, or the main job of Magellan when it gets to Venus, is to use its radar mapper to look at the planet's surface through the clouds. Venus itself cannot be seen even close up because of the density of the cloud layers surrounding the planet. And therefore, the only way to take a look other than actually going down to the surface, which is 800 degrees Fahrenheit and extremely high pressures there, is to look down with instruments that are not looking in the visual part of the spectrum. So a radar will be taking a look and at a much finer detail than has ever been attempted before in order to make a topographical map of the planet Venus, and hopefully to learn a great deal more. Actually, the amount of information which will be coming back from Magellan is more than all of the information which has come back from all of the interplanetary spacecrafts to date. The commander, Dave Walker, has just indicated that he is ready for his weather briefing, and that indicates that the 3 mission specialists are in the process of getting suited up for their trip out to the launch pad. The countdown clock at T-minus 3 hours and holding, just about 36 minutes remaining in this build-in hold. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding with just slightly less than 30 minutes remaining in this 2-hour build-in hold. Commander Dave Walker and pilot Ron Graby have just had their briefing from the Mission Control Center in Houston on the weather here and around the world. And it appears that the only weather concerns at all are here at the Kennedy Space Center. All of the transoceanic abort sites, Ben Guerir in Morocco, which is the primary site, the weather alternate at Morón, Spain, and the Banjul Airport in the Gambia, all have great weather, although the teams from those 3 locations wish the crew a good flight and said that they would not be hurt if they bypassed them. The Edwards Air Force Base, which is the abort once around landing location, also has great flying conditions today, just some light easterly winds, good visibility, no clouds to speak of. Northrop, which is the White Sands Airport in the west, has some gusty winds. However, Edwards would be the primary landing site instead of New Mexico if that were necessary. At the present time, it looks like there is some slight shifts going on here, but the predicted weather at liftoff is still satisfactory. Crosswinds at the shuttle landing facility should just be 8 gusting to 10. That is within the constraints. So we are very hopeful. The crew is very hopeful as they continue with their suiting up at the O&C building in the crew quarters, that this will be the day for launching STS-30 and Magellan. Here in the firing room, earlier the orbiter test conductor had everybody who is monitoring the orbiter switch to the same channel so that every member will be on that when the crew arrives at the orbiter. Landing and Recovery Director Chuck Henschel is presently going through a series of communications checks with the convoy commander who is standing by at the shuttle landing facility in the case of a problem which would require the shuttle to abort its mission and return to the Kennedy Space Center after launch. He also talks to the solid rocket booster recovery ships, the Liberty Star and the Freedom Star, which are standing by to recover the solid motors about 142 miles east of Kennedy Space Center in the Atlantic Ocean. The two ships departed from Cape Canaveral about noon yesterday, and they've gone through an approximately 2-hour electronic and visual search of the impact area to ensure that the area is clear of shipping. At T-minus 30 minutes, the ships will be located 7.5 miles from the predicted impact points of the solid motors. Those solid motors separate from the shuttle at 2 minutes and about 6 seconds into the flight. However, they do not actually impact the water until 7 minutes after liftoff. They continue to fly slightly upward and on a parabolic curve, and then impact 142 miles away from the center. The recovery operation, given good sea states, which we have today, should take just about 5 hours. We have 25 minutes, 43 seconds remaining in this 2-hour build-in hold. The countdown clock at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. In the suit room now with scenes from the crew quarters of Commander Dave Walker in the process of completing his preliminary suiting up for the trip out to the pad. Next to him is the pilot Ron Graby. Ron Graby has about 98 hours in the orbiter Atlantis, which he plans on flying today. He was on 51J, the second DoD mission, and then Mark Lee, he looks like he's about ready for his trip out. Once you get into those suits, they are not as comfortable as the coveralls which they used before. Dr. Mary Cleve and Dr. Norm Thagard on the opposite side of the suit room completing their buttoning up and zipping and that sort of thing. Those suits are basically protective clothing which were made necessary when the decision to install an escape system in the orbiter was made. They will be putting on their parachutes, communications caps, survival equipment in the white room just prior to actually going into the orbiter itself. Norm Thagard will be on his third flight on STS-30. He flew in June of '83 and then on STS-51B. Back pilot Dave Walker, or Commander Dave Walker, peering out from under his helmet. They try to do all of the hookups to ensure that all of the equipment is fitting perfectly so that if there's anything that needs to be taken care of before they go out to the pad, that they do that. We just have about 14 and a half minutes remaining in this build-in hold. The astronaut support person, Bruce Melnick, who is out at the pad, part of the closeout team, has been asked to install the lithium hydroxide canisters in the crew compartment. These canisters are part of the cabin air revitalization system. The cabin air is ducted through the lithium hydroxide canisters, which removes carbon dioxide. And then activated charcoal removes the odors and trace contaminants. During the mission, they have to be changed alternately every 12 hours. Other systems monitor and provide the proper mixture of oxygen and nitrogen for breathing and maintain the proper pressure, humidity, and temperature. Actually, a complete cabin air change occurs every 7 minutes. During this particular flight, they're going to be lowering the cabin pressure from the normal pressure around 14, 15 pounds per square inch down to 10. This is part of the scheme that would be used prior to having to go out on extravehicular activity to get the body conditioned slowly rather than having to have just that person in a special mask in preparations for that. Everything going smoothly in the countdown. We will be coming out of the 3-hour build-in hold just 12 minutes and 50 seconds from now. The countdown clock at the T-minus 3-hour point and holding. This is Shuttle Launch Control. This is Shuttle Launch Control. We just have slightly less than 2 minutes remaining in this build-in hold. There will be 2 additional build-in holds at the T-minus 20-minute point and the T-minus 9-minute point. Both of those will be 10 minutes in duration. At the first launch attempt last Friday, we had added an extra 30 minutes of hold time at the T-minus 9-minute point. However, because we have a much longer window today, that won't be necessary. The ice inspection team has reported it has completed its work and is leaving the pad, and they will report their findings to Launch Director Bob Seek when they reach the Launch Control Center. The mission management team is presently discussing a problem which has been being watched through the latter part of the countdown concerning the temperature of a water spray broiler. That is not expected to be a problem. At the present time, NASA Test Director Ron Phelps has called the crew quarters and verified that the test team and the orbiter are ready to support the flight crew's departure from the crew quarters and their subsequent arrival at the pad. In the next few minutes, the flight crew will leave their third-floor quarters and come down a hallway to the elevator, which will take them to the ground floor, where they'll leave the building and climb into the waiting astronaut van. Just 9 seconds away from picking up the countdown once again at the T-minus 3-hour point. 2, 1, and counting. T-minus 3 hours and counting. At the ONC building, you'll see that there are a lot of well-wishers who are on hand. They have to be kept back at some distance because the flight crew has basically been isolated from people who have not been examined to determine that they will not pass on colds, viruses, etc. During the entire time between the last launch attempt and this, they have remained in an isolated mode. Actually, their families are cleared and have frequent checks, and it's the responsibility of them to ensure that they will not pass along any germs to the crew. At the everybody standing by for the crew to be leaving there. When you take a look again at the ONC building, we'll see that there is a group of news media representatives, as well as quite a few workers who are in an area in between the two buildings there. Because this particular launch is taking place during normal working hours, there's a lot more people who are going to be standing out there to take pictures and to get a glimpse of the crew. The first time we'll see the crew on our NASA Select video will be when they leave the suit room, moving down towards the elevator on the 3rd floor of the ONC building. Countdown clock at T-minus 2 hours, 57 minutes, 40 seconds, and counting. The closeout team out on the pad, ready for the crew arrival. By the time that the astronaut van reaches the pad, there will be suit technicians who will go out down to the pad surface and meet them and assist them in any way possible up to the 195-foot level. The astronauts ride out to the pad in a converted recreational vehicle. In addition to the 5-person crew, which is made up of Commander Dave Walker, Pilot Ron Graby, and Mission Specialist Mary Cleve, Norm Thagard, and Mark Lee, the commander, or the chief of the astronaut office, Dan Brandenstein, and here comes the crew now, being led out really by Mission Specialist Norm Thagard, Mark Lee, Mary Cleve, and the commander and pilot, Commander Dave Walker waving, and Pilot Ron Graby waving as they go into the elevator for the trip down to the 1st floor. That order will be reversed as they come out the door. You can see the crowds kept back away. You don't want to have the crew having a cold in orbit. Usually a number of signs saying good luck Atlantis, and good luck to the crew of STS-30. The people clapping now as they come out of the elevator, being led out by a security specialist, Commander Dave Walker, Pilot Ron Graby waving to the people who are there in the news media, and Thagard, Mission Specialist, waving, Mark Lee and Mary Cleve moving towards the recreational vehicle. There's Chief of the Astronaut Office, Dan Brandenstein. He will be flying the weather aircraft today, and that's going to be a very important task because the weather here is changing, and it still has to change quite a bit before we get to launch time. Dan Brandenstein will be leaving the recreational vehicle earlier than anybody else as it gets to the intersection of the road which goes out towards the pad and the one that goes on towards the shuttle landing facility. It's about a 9-mile drive out to the pad. And it's important that wearing the bulky suits that they be in air conditioning, otherwise they would be very uncomfortable when they arrived. You can see a lot of the people, several hundred workers from that building. That building houses quite a lot of the people who do engineering in the payload world and in the shuttle world, with the Astrovan now moving off on its 9-mile trip out to the pad. It will go out in convoy with an emergency vehicle and with a security escort. The vehicle at the very rear of the convoy, which cannot be seen on the NASA Select television at the present time, will be used if there should be a breakdown of the Astrovan to pick up the crew and continue the trip on out to Pad B here at the Kennedy Space Center, where the shuttle is waiting and ready. Before they leave, they have to have a call from the NASA test director, the orbiter test conductor, to tell them that things are in readiness for their arrival. Actually, this has been quite a smooth countdown. There's really only a couple of very minor problems which have been discussed. Nothing that looks like anything that would stop the countdown today. The weather is expected to continue improving as the sea breeze moves the clouds to the north and in further to the center of the state. But we'll be watching that, and as I mentioned, Dan Brandenstein will be flying NASA aircraft, continuing to check on the visibility that's possible, also where the tops of those clouds are. It's very important that the clouds not go up through the freezing layer, because that increases the potential for a buildup of electrical charges within the clouds. And the convoy on their way out to the pad, during this particular period with the vehicle, pressurization of the helium tanks for the main propulsion system gets underway. This is a task which takes approximately 30 minutes. The helium supply provides pressure to operate the liquid oxygen and liquid hydrogen pre-valves and the onboard and inboard fill and drain valves. The helium is also used for anti-icing purges of the three main engines. The countdown clock at T-minus 2 hours, 51 minutes, 17 seconds and counting. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 2 hours, 46 minutes, 50 seconds and counting. The Astrovan stopping at the intersection of Kennedy Parkway and the turn on Saturn Causeway to go out to the pad to let the Chief of the Astronaut Office, Dan Brandenstein, out of the Astrovan. He is going to continue on now out to the shuttle landing facility, where he will be flying the shuttle training aircraft to continue to keep a watch on the weather. The weather really is the only problem area that we're looking at. As a matter of fact, the orbiter test conductor has just gone through a check of all of the major consoles and managers who are monitoring the launch for this afternoon, to determine that they saw no constraints to the crew getting on board. The van will pause once again in just a minute to allow the Director of Flight Crew Operations, Don Putty, and astronaut trainer Rick Nygren to get out of the Astrovan before it moves on to the pad. They'll be coming up into the Launch Control Center, where they will continue to monitor the preparations for launch at 1:48 this afternoon. From this point, it's just about 3.5 miles more out to the pad. And out at the pad, the suit technician coming down the elevator to meet the van and assist the crew. Some well-wishers standing out there from the Launch Control Center who are not involved in the activities getting ready for launch, waving at the crew as they go by. ICE team leader Charlie Stevenson back here at the Launch Control Center and preparing to give his report on the conditions which the ICE team saw out at the pad. The countdown clock at T-minus 2 hours, 44 minutes, 20 seconds and counting. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 2 hours, 40 minutes and counting. NASA Launch and Landing Director Chuck Henschel has started a communications check with the convoy commanders here at the Kennedy Space Center and the solid rocket booster recovery ships. He's asking for a status of the landing aids, such as the runway lights, the microwave scanning beam landing system, the tactical air navigation system, the PAPI and ball bar lights, and the tracking system antenna, which transmits and receives communications from the launch vehicle. The telemetry system has now been verified to be operating properly. The Astrovan now has made its way past the roadblocks and is proceeding to the pad surface, where the astronauts will get out and take the elevator to the 195-foot level of the fixed service structure. There, they will walk across the crew access arm and into the white room where they'll put on the rest of their escape equipment and helmets before entering the orbiter. The closeout crew has been making final preparations for the crew arrivals. Switches in the cockpit have been covered by astronaut Bruce Melnick to ensure that the crew members do not inadvertently brush against those switches, which cause the reaction control jets to fire in their bulky pressure suits while getting into their seats. The Astrovan has come to a stop now, and the crew leaving the van and walking over to the elevator, where they'll be going up to the 195-foot level. Switches have also been configured to the proper settings to prepare the vehicle's electricity-producing fuel cells for using the onboard cryogenic reactants when ground supplies are terminated about 3.5 minutes before liftoff. The orbiter navigation aids, the tactical air navigation and radar altimeters have also been activated. STS-30 Lockheed Orbiter Test Director Mike Key polled all of the various test conductors and verified there are no violations of launch commit criteria at this time. The only thing which we continue to watch is not expected to be a problem is the temperature of the water spray boiler. Astronaut support person Bruce Melnick has also cleared the orbiter's caution and warning memory, and the crew now has arrived at the 195-foot level and are walking across the orbiter access arm, where the closeout crew is waiting, and the first people to be entering the orbiter, shaking hands now with that closeout team, Commander Dave Walker and pilot Ron Graby. The crew will be putting on their escape equipment here in the white room just before getting into the orbiter, and that equipment consists of an emergency oxygen system, a parachute harness, parachute pack with automatic opener, a life raft, 2 liters of emergency drinking water, flotation devices, survival vest pockets including a radio beacon, a signal mirror, shroud cutter, pin gun flare kit, sea dye marker, smoke flare, and beacon. The commander, Dave Walker, and pilot Ron Graby will also put on their launch and entry helmets when they're in the crew compartment, but the rest of the crew should put them on prior to entering the orbiter. It takes approximately an extra half hour, about more than an hour and a half, for the entire crew to enter the orbiter and be strapped securely in their seats. The countdown continuing to go smoothly at T-minus 2 hours, 35 minutes, 20 seconds and counting. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 2 hours, 30 minutes and counting. Commander Dave Walker has entered the orbiter now and is making his way up to the crew cabin, where he'll be getting into his seat and having the seat adjusted and the rudder pedals and other things to make sure that he's able to reach the controls on the orbiter properly. Pilot Ron Graby standing by. He'll be the second person to enter the orbiter today. and he'll be followed by Mission Specialist 3, Mary Cleve, who'll be sitting in the middeck area, and then Mission Specialist 1, Mark Lee, and Mission Specialist 2, Norm Thagard, who will sit on the flight deck. The first thing that the crew puts on normally when they're in the white room is the liner for the helmet, which contains a microphone, earphones, and connectors for plugging into the orbiter control panels. Once the helmets are on, they provide protection for the crew members' heads and faces. They reduce light and sound level in the crew compartment and provide better communications by cutting down on the level of noise during launch and directing the crew voices into the microphones so that more intelligible air-to-ground communications can be maintained during the powered phase of the flight. Each crew member is attached to an emergency oxygen system, which is used in case of failure of the cabin system to provide clean air either during the flight or after a landing if there should be hazardous gases around the orbiter. The helium tanks in the main propulsion system have completed their pressurization process, which started approximately a half hour ago. Everything continuing to go smoothly as we move towards a launch at 1:48 this afternoon. The countdown clock at T-minus 2 hours, 27 minutes, 38 seconds and counting. This is Shuttle Launch Control.
PPE, OTC. PPE, go ahead. Yes, sir. Step 370. Are we going to perform that? Stand by one. Got the firm OTC. Those will be performed steps. Copy, thank you.
CGLS 212.
Go ahead.
Yes, sir. I want to go ahead and report completion of step 358 through 366. And we'd like to go for step 370, please.
You have a go.
Thank you. OTC, CMTC.
Go ahead.
What was the steps that GLS just called in?
That was 358 through 366.
Copy. And you gave her a go on what step?
370.
Copy.
OTC, TPE 212. Go ahead. Yeah, we were just informed by the payload people that that we can go ahead and increase the purge circuit 2 temperature to 60 degrees. And we need to do that. Okay, copy that. PVD, you copy?
We copy.
CNSC, OTC 212.
CNSC, go.
Okay, your Talfite TACAN thumb wheel setting remains 118 X-ray.
Acknowledge, and we'll take a not perform on step 446.
Copy.
OTC, CDR, how do you rate?
Read you loud and clear, CDR. How many?
You're loud and clear.
Good morning.
And good morning to you. NTD, CDR, how do you rate?
CDR, NTD on air-to-ground 1, how do you read?
You're loud and clear. Good morning.
Good morning, sir. Got a good ship out there today.
We think so, too. Houston, Atlanta, CDR, how do you read?
Atlanta, CDR, Houston, you're loud and clear. Good morning, Dave.
Morning, Frank. OTC, CDR, I'll be moving my seat for a few minutes.
Copy, CDR.
This is Shuttle Launch Control at T-minus 2 hours, 20 minutes and counting. Pilot Ron Graby now has entered the orbiter as well as the commander Dave Walker. And you've been hearing Dave Walker begin his checks with the through the communication system with the Launch Control Center here and with the Mission Control Center in Houston. Dave Walker is a captain in the U.S. Navy, and he was selected for the astronaut program in 1979. He flew as a pilot on STS-31A, which, in addition to deploying 2 satellites, also retrieved 2 satellites, and this was the first time that satellites were retrieved in orbit and returned to Earth. Walker was born in Columbus, Georgia, but he considers Eustis, Florida, to be his hometown. That's where he grew up, and he's a graduate of the U.S. Navy Academy. Pilot Ron Graby actually will be handling a lot of the systems and backing up the flying. It's a little bit of a misnomer. The commander actually does most of the flying, and the pilot is sort of the co-pilot. However, he would orchestrate a extravehicular activity going out of the crew cabin into the payload bay if necessary. He's a colonel in the U.S. Air Force, and he flew as a pilot on STS-31J. This was the second space shuttle mission for the Department of Defense. He's a graduate of the U.S. Air Force Academy, and he earned a Fulbright scholarship to study aeronautics at the Technische Hochschule in Darmstadt, West Germany. He's a native of New York City. The next of the mission specialists to finish their suiting up will be Mary Cleve. Mary Cleve is responsible for orchestrating the secondary payloads and the photography on board the orbiter. The secondary payloads include the experiments with the mesoscale lightning experiment, and then also some crystal growth experiments. Dr. Cleve getting into the orbiter now. She has a degree in biological science from Colorado State University and a Master of Science degree in microbial ecology and a doctorate in civil and environmental engineering from Utah State University. She's also experienced in space flight, having served as a mission specialist on STS-61B. The practice which the crew received on the launch attempt last Friday obviously paying off as they are suiting up and going through their process of entering the orbiter much faster today.
Flight crew systems DR is complete.
Mission specialist Barry Cleve will be sitting on the mid-deck of the orbiter during launch and the landing process.
That was DR double balls 23.
I copy. That is complete.
Okay, would you report?
At this point, also, the sound suppression water tank on the pad is topped off if necessary. That tank holds approximately 300,000 gallons of water, but it's emptied within 20 seconds as water flows through the sound suppression system onto the mobile launcher deck, sprays through the engine exhaust ports at a rate of 1 million gallons a minute. The water prevents damage to the orbiter, which could be caused by the magnitude of the sound energy coming from the main engines and solid rocket boosters at liftoff. Everything continuing to go smoothly. The countdown clock at T-minus 2 hours, 15 minutes, 42 seconds in counting. This is Shuttle Launch Control.
OTC, CMQC.
Go ahead.
Yes, sir. Sequence 16, step 1027. We're adding constraint, line item 71.
Okay. Repeat, please.
At sequence 16, 1027. We're adding line item 71.
Copy.
CTLS on 212.
Go ahead.
Yes, sir. We need to request an LPSer to come out and take a look at our printer plotter at integration, please.
LPS, OTC.
Just LPS.
Yeah, can someone come out the integration console and check the printer plotter, please? I'll send somebody out.
OTC, CMQC. Go ahead. Yes, sir. Constraint line item 69 at step 160591 has been cleared.
Copy that. Thank you. DVD, OTC.
DVD 212.
Yeah, just information from payloads. When we reduced our payload bay purge at, what is it, T-minus 10? At that point in time, they'd like to see a temperature of like 58 degrees in there.
Copy. Understand.
Okay.
OTC, PLT, radio check air to ground 1. How do you read?
Read you loud and clear, PLT. How me?
Loud and clear as well. Good morning.
Good morning to you, sir.
NTD, PLT, radio check. How do you read?
PLT, NTD, read you 5 by. How me?
5 by as well. Good morning.
Good morning to you, sir.
And Houston, Atlantis, PLT, radio check.
Atlantis PLT, Houston, you're loud and clear. Good morning, Ron.
Good morning, Frank. You're loud and clear as well.
OTC, TPE. Go ahead, TPE. Yeah, request to speak to CGNC over on his channel 141. GNC, OTC. CGNC, OTC. Go ahead. Yeah, can you go over to 141 and talk to TPE? Sure.
OTC CGLSN 212.
Go ahead.
Yes, sir. I'd like to report completions on step 370 through 377. All steps performed.
Copy that. CMQC, you copy?
That's primitive.
Go ahead, SPM. CMPS, OTC.
CMPS, go.
Yeah, we're still working our helium tank pressurization.
We called that incomplete.
Copy. HGD, OTC.
This is CHD, go ahead.
Okay, I'll give you step 381.
All right, copy. Thank you. OTC, MPS.
Go ahead.
That was step 378, 79, and 80.
Yeah, copy that, sir. Thank you.
This is Shuttle Launch Control at T-minus 2 hours, 5 minutes and counting. 3 of the 5 crew members now in the orbiter. You've been hearing pilot Ron Graby do some of his communications checks. These are preliminary checks. And mission specialist Dr. Norm Thagard in the White Room now, waiting for his turn to put on the emergency equipment and enter the orbiter too. Dr. Thagard is a medical doctor, and he's making his 3rd flight aboard a shuttle on this mission. He served as a mission specialist on STS-30, and during that flight he conducted several medical experiments and collected data on physiological changes associated with astronaut adaptation to space. He also served as a mission specialist on 51B. Dr. Thagard originally earned bachelor and master's degrees from Florida State University in engineering science, and then in 1966 he entered on active duty in the U.S. Marine Corps Reserve. He attained the rank of captain and qualified as a naval aviator in 1968. He flew 163 combat missions in Vietnam before returning to college in 1971 to pursue additional studies in electrical engineering and a degree in medicine. Prior to joining NASA, he was interning in the Department of Internal Medicine at the Medical University of South Carolina.
Go ahead. Okay, sir. We'll perform our post-in
There's not a lot of room in the white room, which is used for the final preparations before entering the orbiter, and therefore frequently the astronauts stand out on the walkway. You also get a better view out there, 195 foot up from the pad, and one of these spectacular vantage points along the Space Coast.
Driver switches on.
Launch Director Bob Seek has been getting a special weather update to take a look at what's happening out there in the skies. The forecast is sort of touch and go as far as how fast those clouds are going to move and what the winds will be at the shuttle landing facility at launch. There's no basic problem at the present time as far as the clouds are concerned. There's really no thunderstorms in the area, and that is expected to stay the same. We're hoping that the clouds will move toward the west and get out of the area here of the Kennedy Space Center in time for an on-time liftoff at 1:48. We do have a 64-minute window today, much longer than the 23 minutes we had on Friday, but it's still not long in terms of waiting out changes in the weather. But the forecast says that we have a 60% chance of being able to go, and we're continuing on with the count at T-minus 2 hours, 1 minute, 25 seconds, and counting. This is Shuttle Launch Control.
OTC, ASP, you are broken by the weather plane. Give me a go-ahead again for 016.
Okay, 016, RJDA 2B, 2A, and RJDF 2B, driver switches on.
That's complete.
Copy. Right on engine valve switch on.
That's complete.
And unguarded, I assume?
Unguarded, that's firm.
Thank you. COFC, OTC.
SOFC, go ahead.
Okay, steps 438, 439, and 40 and 41.
Can work.
And OTC, ASP, we're standing by the GPC output switch.
Copy that, sir.
OTC, GLS 212.
Go ahead.
Yes, sir. I'd like to get a go-ahead for my initialization at step 491, and I would need a CMQC on channel 183.
Copy. CMQC, OTC.
CMQC.
Okay, need someone on 183.
Thank you, and the following step is PEP dual interrupt notification will be activated momentarily. That's step 492.
Copy.
OTC, COFC 212.
Go ahead.
Yeah, 438 is complete, 439 is complete. I'll verify the OMRSD. 440 and OMRSD are complete. 441 is also complete at this time.
Copy that. ASP, OTC.
Go ahead.
Okay, on panel 06, GPC 5 output switch to backup.
Stand by. That's complete.
Okay, copy that, sir. And CMQC step 443 is not performed.
Copy.
446 is not performed. 444 and 45 were completed earlier. 47, 48, and 49 are not performed. And the ASP has just completed the last switch in this reconfiguration, so we are complete per 450.
OTC, CGSS.
Copy.
Go ahead, sir.
Yeah, 499 and 500 complete at this time.
Copy that, thank you.
OTC, ASP.
OTC, CMQC.
Stand by CMQC. Go ahead, ASP.
Post ingress switch reconfig complete. I'll be adjusting the caution warning alarm, and master alarm will be tripped.
Copy that, sir. ISL, PPE, you copy? ISL copies. PPE, copy. And you can reset, sir. TPE OTC. TPE, go ahead. Yeah, step 451, terminate the any change switch cam monitor program. Copy, Wilco.
OTC, CBSE 212.
Go ahead.
I want to advise you that sequence 16-0507, biomed data that's not performed today.
Copy that, thank you.
Thank you.
CMQC OTC.
CMQC.
Yeah, you called earlier?
Yes, sir. Did you get the fill-ins at step 446? I beg your pardon, that's not performed.
That's not performed.
Copy.
OTC asked the caution warning balance has been adjusted. That's complete.
Okay, I copy that, sir. And CMQC, that's steps 520 through 524.
Copy. OTC MS3, how do you read?
I read you loud and clear, MS3. How many?
Loud and clear.
And good morning.
NTD, MS3, Air Ground 1, how do you read?
MS3 is NTD, read you 5 by. How many?
Loud and clear.
We'll have a good flight for you today.
Appreciate that. Houston, MS3, air to ground. How do you read?
Atlantis MS3, Houston, you're loud and clear. Good morning, Mary.
Morning.
Before you do that, go ahead and push the test on your suit valve.
This is Shuttle Launch Control at T-minus 1 hour, 50 minutes and counting. The ground launch sequencer computer program has been started in the integration console here in the firing room several minutes ago. Engineers will now set up the specific tables in the launch processing system that the ground launch sequencer will use as its guidelines to either let the countdown continue or call an automatic hold when it assumes control of the countdown at the T-minus 9-minute point. The status of the solid rocket booster retrieval area is reported to the Landing and Recovery Director, Chuck Henschel, is favorable. The SRB recovery ships left Port Canaveral yesterday, and they leave about 24 hours before launch. The simulation of the first motion of the shuttle has been sent to the Johnson Space Center. Range safety and firing room also test the system, which indicates liftoff. This signal also starts the clock, which keeps track of the mission time. Mission Specialist Dr. Norm Thagard moving into the orbiter now. He has been standing there waiting his turn. And one more to go, Mission Specialist Mark Lee.
MS1, NTD, read you 5 by. How many?
Good morning, loud and clear. Houston, Atlantis, MS1, how do you read?
Atlantis MS1, Houston, you're loud and clear. Good morning, Mark.
Mission Specialist 1, Mark Lee, in the orbiter. He's going to be primarily responsible for the deployment of the Magellan spacecraft. He will be watching, sending the signal which turns on the spacecraft and resetting the recorders if necessary from the orbiter. Mark Lee is the only rookie on this flight. He's a major in the U.S. Air Force, and he was selected for the NASA astronaut program in May 1984. He is a graduate of the U.S. Air Force Academy and earned a master's degree in mechanical engineering from MIT in 1980. people here in the firing room, the control room, which monitors all of the launch activity here, heartened by the fact that the clouds appear to be breaking up somewhat and the sun has been appearing more and more frequently. The weather really is the main concern as we go through this final couple of hours of the launch countdown. We are expecting that the weather will be moved to the mainland from off the coast by the sea breeze as it becomes more active and as it shifts. At the time of launch, it's expected that that will be from just about 10 degrees south of east.
Yes, sir. The whole available timers have been configured at this time. That's steps 493 through 495.
The heaters in the solid rocket booster hydraulic control systems have also been turned on. They'll be used to start the decomposition of the hydrazine fuel, which is used to turn the turbines, supplying power to the hydraulic pumps, which in turn allow the huge nozzles to be moved for steering purposes during the flight. The closeout crew now is in the process of starting to remove some of the platforms, which are used for allowing the crew to get into their seats in the orbiter. It's always a little tricky because the orbiter is in a vertical position, and the normal way for boarding it would be in a horizontal position. So the crew has to climb up special ladders. They have to use special flooring that's put in to protect what during the flight will really be the walls. Everything continuing smoothly. The countdown clock at T-minus 1 hour, 45 minutes, 14 seconds and counting. This is Shuttle Launch Control.
Okay. It's 495A through B.
That's firm.
Okay, copy that. CGLS OTC. CGLS OTC 212.
CLS, go ahead.
Yes, sir. You did perform the permanent D495 Alpha through Dog.
Yes, that's correct. We did perform that.
Okay, thank you. You copy CMQC?
I copy.
OTC, TPE.
Go ahead, CPE.
Yeah, I would like to speak to CHYD on his net 182.
HYD OTC.
HYD copies, going to 182.
Thank you.
OTC, MS2, air to ground 1. How do you read?
I read you loud and clear, MS2. How me?
You're the same, MS2 out.
Morning, sir.
NDD, MS2, air to ground 1. How copy over?
MS2, NTD, on air to ground 1, read you 5 by, how many?
And you're the same, MS2 out. Houston, MS2, air to ground 1. How copy over?
Atlantis MS2, Houston, you're loud and clear. Good morning, Norm.
Good morning.
OTC to all systems. Verify all systems ready for crew module closeout. MQC, that's step 528.
Copy.
And ASP OTC.
Go ahead.
Closeout crew module for flight.
Roger, in work, and we're ready for astrocom and air to ground checks.
Okay, copy that. CDR OTC, air to ground 1.
OTC, CDR, loud and clear.
Okay, sir. Can you verify each member of the flight crew is ready to proceed with astrocom checks?
We are ready.
Okay, copy that, and during the com checks, adjust your appropriate volume controls for comfort. And we'll start off on air to ground 2, and if you'll all answer up in turn, we'll go through these rather quickly.
Okay.
And flight crew, this is OTC on air to ground 2. How do you read?
Loud and clear from CDR.
KLT, that's you loud and clear.
MS1 loud and clear. MS2 loud and clear.
MS3 loud and clear.
OTC copies, and next we'll go to ICOM A.
KLT, loud and clear.
MS1 loud and clear. MS1 loud and clear.
This is OTC on UHF flight crew. How do you read?
CDR, loud and clear. KLT, loud and clear.
MS1 loud and clear. MS2 loud and clear.
MS3 loud and clear.
Copy that, flight crew, and that completes our checks. Thank you.
OTCF.
Go ahead, sir.
Roger, I'm ready to terminate comm with the LCC.
Copy that, sir.
To a downlist dump, or to a GPC dump, and when we do that, we will lose downlist for a few seconds.
Okay, copy that. OTC to all systems. Do you copy TPE? DPS? This is DPS, we copy. Okay. EPD? Copy. ISL? ISL copies. Okay.
This is Shuttle Launch Control at T-minus 1 hour, 35 minutes and counting. A lot of discussion going on at the present time. We're coming up to a period at 1 hour and 20 minutes where the countdown could be stopped in order to uplink, in this particular case, what are known as the I-loads. These are really the computer parameters which are used for guiding the shuttle following liftoff up through the atmosphere, taking into account the various stresses that would be seen on the orbiter. They've made a decision that they will be able to go with the normal I-loads and therefore will not have to stop the clock as long as the uplink of those I-loads from the Johnson Space Center to the orbiter is satisfactorily completed, and that process is in work at the present time. The computers on board the orbiter can be updated at various times throughout the countdown, and this is one of those times when they try to have all the preparations done prior to getting further on into the count. We can actually update the I-loads at the T-minus 9-minute point, but at that point we would have to hold, and it would take a longer period than doing it right now. It appears that we will not be stopping at the 1 hour 20-minute point, but that is a possibility if the I-load update is not satisfactory, or if there's a determination that the normal one would not be able to be used today and they want to use an alternate I-load update. As we come up on the T-minus 1 hour 30-minute point in the count, you'll hear the booster test conductor directed to perform a calibration of the solid rocket booster chamber pressure transducers. These transducers measure the pressure in the thrust chamber at the nozzle, and this information is used to tell the computer when to separate the solid rocket motors. The separation procedure begins when the chamber pressure falls below 50% of normal. At the 1 hour 30-minute point, the booster engineers will also go through the test of the rate gyro assemblies, during which they simulate the effect of flight as far as the rate gyro is concerned with the magnetic field, and then measure whether or not it is reading properly. Up in the white room on the 195-foot level of the pad, the closeout team is in the process of getting ready to close the hatch on the orbiter. The astronaut support person is gathering together the materials which are needed inside the orbiter during the entry of the crew and in preparation for them to get on board. However, are not needed during the flight. The work going along ahead of schedule slightly. The crew all on board and in the process of beginning their various types of communications checks. The iLoad process underway now in the updating of the computers. The countdown clock at T-minus 1 hour, 31 minutes, 9 seconds and counting. This is Shuttle Launch Control.
Atlantis, Houston, we're ready for air-to-ground voice checks. We'd like CDR and PLT configured for air-to-ground 1.
Okay, Frank.
Atlantis, CDR, Houston on air-to-ground 1. How do you read?
Houston, Atlanta, CDR, loud and clear.
You're loud and clear also, Dave. PLT, how do you read?
Houston, Atlanta, PLT, you're loud and clear.
You're loud and clear also. Configure for air-to-ground 2 voice check. Atlantis, Houston on air-to-ground 2. CDR, how do you read?
Loud and clear, Frank.
You're loud and clear also. PLT, how do you read?
PLT has you loud and clear, air-to-ground 2.
Roger, you're loud and clear also. Configure for UHF. Atlantis, Houston on UHF. How do you read, CDR?
Atlanta, CDR, read you loud and clear.
You're loud and clear also. PLT, how do you read?
PLT has you loud and clear, UHF.
Roger, you're loud and clear also. All flight crew configure for SIMO voice check. Atlantis, Houston, SIMO, how do you read, CDR?
Houston, Atlanta, CDR, loud and clear.
Roger, no echo problem, right, Dave?
Nope, sounds perfect, Frank.
Roger. PLT, how do you read?
Houston, Atlanta, PLT has you loud and clear, SIMO.
Roger, you're loud and clear also, Ron. MS1, how do you read?
MS1 has you loud and clear.
Roger, Maggot, you're loud and clear. MS2, how do you read?
Houston, Atlantis, MS2 has you loud and clear, Frank.
Roger, you're loud and clear also, Norm. MS3, how do you read?
Houston, Atlantis, MS3, you're loud and clear.
Roger, you're also loud and clear, Mary. Y'all have a good flight.
Call personnel on...
Thank you, Frank. We intend to.
All personnel, channel 212 in the firing room, be advised there will be a momentary loss of downlift and DTS OTC.
DTS, go ahead.
Okay, how about your orbiter GMT and Met Delta adjust? Would you be ready at this time to pick that up?
We'll pick that up per the clock.
Copy that.
And the downlift dump has already occurred. That's complete.
OTC CGNC? Go ahead. Yeah, if I could get a CMQC on channel 141 in preparation for step 593 and 594. And if I could get you go ahead on those steps per the clock. Okay, you have a go at this time per the clock and CMQC OTC. CMQC OTC 212.
CMQC.
Right, we need your support on channel 141, please.
That's right.
OTC, CWS.
Go ahead, double S.
Yes, sir, I'd like to verify step 526.
526, okay, thank you.
OTC, OVCC.
Go ahead, OVCC.
Yes, sir. Seal leak test and continuity check were both successful. We're ready to proceed with cabin leak check.
Okay, we copy that.
That'll be with ECL.
That's firm. And CMQC, OTC.
CMQC, go ahead.
All right, step 599.
Copy. OTC ECL.
Go ahead, ACL.
Can I get a CMQC on 143?
All right. CMQC, OTC.
Copy, 143.
And ECL, OTC, 212.
OTC ECL.
Right, you ready for a cabin leak check at this time?
We're ready.
Copy that. CDR, OTC, air to ground 1.
CDR, go.
Okay, we'll be picking up on the cabin leak check momentarily on panel L2A1.
There.
The cabin vent, the vent ISO switch open until the vent ISO talkback open.
That's complete.
And the vent talkback is closed.
So that talkback is closed.
Copy that. ACO, step 602.
ECL verified.
Copy.
OTC, HYD.
Go ahead, HYD.
Yes, sir. I'd just like to inform the crew of a water spray boiler anomaly.
Okay, stand by just one, please. ECO, OTC.
Yes, ECL.
Okay, you have a go on cabin pressurization and cabin leak check for step 603.
We copy. It'll be on work. OTC, CVFS.
Go ahead.
Yes, sir. Can I talk to QC for just a second?
Yeah, let's go over your channel.
We're doing something. What I'm trying to find out is if there is a DEV that they have recorded to volume 2, sequence 16, step 516.
You copy, CMQC?
Copy. OTC, Phil.
Go ahead.
Yeah, we'd like to have the CDR monitor for mass alarm here when we bring pressure up and let us know when that happens.
Copy that. CDR, OTC.
CDR, will go.
Copy.
OTC.
That's affirmative.
CHYD, OTC.
HYD.
Okay, and CDR, OTC.
CDR, go.
Okay, go ahead, HYD.
Okay, what we've got here is, as we discussed yesterday in the L-1 day briefing, the way our temperatures are on the spray boiler right now, we will not get a spray boiler OK, which adds to give you your APU HYD ready to start talkback on panel R2. So the way things are right now, you would not get a gray talkback on system 2. And when we go to internal power later, if we get
This is shuttle launch control at T-minus 1 hour, 20 minutes and counting. The closeout team up there in the white room on the 195-foot level of the pad are in the process of completing closing up the hatch. Once they have it sealed, which they have at the present time, then they remove the handle that's used during the period that it's open, and they put insulation plugs in the holes to protect it from the heat that it might encounter primarily during re-entry. That process underway at the present time. Commander Dave Walker has been asked to perform the cabin leak check, and that is in work. And the crew was being briefed on the problem with the water spray boiler temperature, which has been talked about periodically during the last few hours of the countdown. This is not expected to be a problem, but they may not be able to see a temperature on that because it would be off scale. They've taken a look at all of the functions and the reasons, and have increased the temperature in the area where that water spray boiler is located to try to get the thing back on scale where they can read it properly. but the temperature actually is not a problem as far as the operation of it's concerned, unless it should get too cold and freeze. The mission management team has discussed the water spray boiler, and it appears that that will not be a problem as far as the launch is concerned today. The weather continuing to improve here at the Kennedy Space Center, as the weather people thought it probably would. Most of the clouds now in the pad area are gone, and the clouds continue to move in a westerly and slightly northerly direction. At the shuttle landing facility 4 miles west of the pad, the convoy which would support the shuttle orbiter should it have to return to the landing facility is being positioned for such a contingency. The convoy is made up of a number of vehicles, including a purge truck which flows air through the vehicle to ensure there's no buildup of toxic gases, a cooling vehicle which provides Freon for the orbiter's coolant system to reject heat produced by electronics and other systems on board, a special white room and stair truck for the astronauts to use in exiting from the vehicle. Also, personnel wearing special self-contained breathing suits called scape suits are on hand. They are not suited up at the present time, but they would be the first to be on the scene in case of a landing, using instruments to sniff the atmosphere around the vehicle to make sure there were no toxic propellants escaping that might endanger the landing support crew or the astronaut team when they exited the vehicle. We have passed the 1 hour 20-minute point, which was an emergency hold period. The iLoads, which we discussed earlier, have been uplinked to the vehicle, and they decided that they could go with the standard iLoads that they had planned for today. If the wind shift occurs in the upper altitudes, we would be able to upload a new alternate program at the T-minus 9-minute point. However, that's not expected. The determination of what computer programs you place in the orbiter to use for steering up through the atmosphere is based on information coming back from various types of balloons. These balloons are launched periodically, starting the day before the mission, and then becoming more frequent in the last 6 or 7 hours. The information from them run through a computer to see the directions and the velocity of the winds as they go up. The Gymosphere balloons, which are used to go up close to 60,000 feet, and we have seen top winds at about 90 knots around the 40,000 foot level today. However, very little wind shear, which is winds that are blowing in different directions at different altitudes. So we appear to have everything going along very smoothly at the present time. The crew in the cabin, the hatch closed, cabin pressure underway, and the weather appears to be cooperating with us.
Yes, sir.
And the countdown clock continuing at T-minus 1 hour, 14 minutes, 20 seconds and counting. This is Shuttle Launch Control.
LTC, TP.
Go ahead.
Yeah, during this quiet time, I'll pass along to you, the payload community gave us a goal to not lower the purge circuit 2 temperature, so we'll stay where we're at 60 degrees right through T0.
Okay, copy that, sir. Thank you.
OTC, CMQC.
Go ahead, sir.
We don't have any verification on that at this time.
Copy.
OTC, CVFS.
Go ahead, sir.
Yes, can I please get QC over to 152?
CMQC, OTC.
CMQC.
Someone on 152, please.
Copy.
This is Shuttle Launch Control at T-minus 1 hour, 10 minutes, and counting. The pre-flight calibration of the inertial measurement units, which started back at the T-minus 5 hour point, has been completed. The systems engineer at the Guidance, Navigation, and Control Council reports that he's ready to proceed with the IMU attitude determination as soon as the Greenwich Mean Time adjustment is complete. The mission timer can show either Greenwich Mean Time or mission elapsed time and can be adjusted to within 1/1,000,000th of a second, either by ground command via uplink through the onboard computer or by the flight crew through their use of their flight deck display and control panel keyboard. The inertial measurement units are used to tell the guidance systems on the orbiter where it is in relationship to its launch pad here at the Kennedy Space Center. Each IMU contains 2 accelerometers to sense accelerations of the vehicle and 2 gyroscopes to provide a stabilized 4 gimbal platform to provide attitude and velocity information with respect to known coordinates. The navigation system used by the shuttle uses a standard reference point that is based on the position of the stars as they were at the time of the vernal equinox in the year 1950. The complicated process of aligning the IMUs begins when the units are calibrated during the early part of the countdown. The next step, the one about to be accomplished, is to make the transition from a calibration into an operational mode. Then at the T-minus 61 minute mark, the IMUs transition again into their pre-flight alignment mode, which will continue until the units are set to inertial at T-minus 20 minutes. In orbit, the IMUs must be realigned periodically, and this is done with the 2 star trackers. The star trackers are mounted on the same fixed platform as the IMUs in the forward section of the orbiter. The astronauts select 2 stars from the 50 stars in their catalog, and they pick stars that are about 90 degrees apart and use this for updating the alignment of their navigational system as they circle the Earth. The countdown clock continuing at T-minus 1 hour, 7 minutes, 18 seconds and counting. This is Shuttle Launch Control.
OTC ECL.
Go ahead.
You can notify pad leader to continue the hatch closeout per op support setup 20 at this time.
Copy that. OBCC, OTC. OBCC, OTC.
Go ahead, just go OBCC.
Okay, per ECL, you can continue your hatch closeout at this time.
We copy, that's in work, sir. Safety wires going on the cap now.
Thank you. CGNC, OTC. Go ahead. Yes, sir. Are you going to be ready for your pre-flight align by the clock?
Will do.
Okay, I'll give that to you by the clock, 6:05.
Copy.
CCME, CSME, OTC. CCME. Yeah, you ready to go ahead and set up your printer plotters?
Oh, we can do that. That's SME.
You ready to set up printer plotters now?
Copy that for 610.
Yeah, that's affirmative. Okay, we'll get LPS over.
Okay.
LPS, OTC.
This is LPS.
Yeah, we want to go ahead and put step 10 into work. 610, I'm sorry.
Copy 610. We'll get those plotters online.
Thank you.
OTC ECL.
Go ahead.
For step 679, the crew module press and cabin leak check is complete, and we're ready for cabin vent redundancy config.
Copy that. CDR, OTC.
CDR, go.
Sir, I'd like to go ahead and perform our cabin vent redundancy configuration.
Okay, I'm ready.
Okay, panel L2, A1.
I'm there.
Vent isolation switch closed until the vent isolation talkback shows closed.
That's complete.
Copy that. And vent switch open until vent talkback open.
Say the cabin vent is open and the talkback is open.
Copy that. Thank you, sir. ECL, you copy?
ECL copies. OTC, OBCC.
Go ahead, sir.
Top support STS-30 is complete.
Copy. Thank you. Okay, you verified the ECS damper is closed.
That's verified.
Copy that. That's step 706 CMQC. And CMQC, how are we doing on our verification of out support setup 2?
That's still in work.
Copy.
This is Shuttle Launch Control at T-minus 1 hour and counting. The commander, Dave Walker, has reported that he has completed the first of the cabin leak checks. During these leak checks, the commander closes the cabin vents and the cabin slowly pressurizes from its normal sea level pressure of 14.7 pounds per square inch up to 16.7 pounds per square inch. And as the pressure increases, the environmental control engineer in the firing room monitors the status of that test. The higher than normal pressure causes alarms in the cabin to go off, and that also serves as a test of the cabin's caution and warning system. Additional cabin leak checks are performed later in the countdown. The Eastern Test Range safety hold fire checks have also been completed. These things being completed a little bit early today as the launch team goes through the countdown with very little problems. And we've heard from the operations manager, Bob Crippen, that the water spray boiler concern, which had to do with the temperature of that water spray boiler, has been improving continuously. The concern really has to do with being able to tell what temperature it's at just prior to starting the auxiliary power units. It's used to cool those units when necessary, and it does that by spraying water on the surface to carry away the heat. During the earlier part of the countdown, the water spray boiler was colder than it normally is, and as a result, the temperature was off of the scale of the instruments that measure that. It was not considered to be a major problem, but it's always nice to have it working exactly right. Continuing to watch the weather, we've been informed that right at the moment we have a crosswind violation as far as return to launch site aboard is concerned at the shuttle landing facility. That crosswind up to about 14 knots and gusts. The weather, of course, continues to change as the ocean breezes come into play as we get into the afternoon, and the heating by the sun changing the direction of the wind slightly, and also the cloud layers. The pre-flight alignment of the inertial measurement units was started on time just about 3.5 minutes ago. The pre-flight alignment will be completed during the hold at T-minus 20 minutes, just before we put the onboard computers into their final countdown configuration. The pre-flight alignment cannot be completed more than 10 minutes prior to the computer transition to what is known as Ops 1, which occurs when the team comes out of the T-minus 20-minute hold. However, if it's delayed longer than the 10 minutes allowed, then the pre-flight alignment must be performed again. The safety officials have confirmed that fire and rescue personnel will be on station at the shuttle landing facility and just outside the pad blast danger area by the T-minus 30-minute point.
Go ahead.
The countdown continuing very well as we move towards a launch at 1:48 p.m. Eastern Daylight Time. This is the second launch attempt for STS-30 and the Magellan spacecraft to Venus. The first one last Friday was stopped because of a problem with a recirculation pump on engine number 1, which is used for moving the liquid hydrogen through the engine area back into the external tank to keep the temperature and condition of that suitable for the start of the engines. That pump was changed. They also changed a 4-inch recirculation line, which was a line that carries the liquid hydrogen back to the external tank. Although it was suspected that there was a leak in the outer chamber of that line, it turned out that there was not, and that it was not the problem once it was understood that it was originally thought to be. Things going along quite smoothly. The countdown clock at T-minus 54 minutes, 50 seconds and counting. This is shuttle launch control.
We need a not performed option on that step.
Yes, sir. That's page 336 of volume 1, 27.
Okay, copy that. Stand by 1.
OTC, CMQC.
Stand by, please. RCRE, OTC.
RCRE.
Yes, sir. Can you pick up step 629 at this time?
Okay, step 629 is complete.
Copy that. Thank you. CAFM, OTC. This is AFM. Yes, sir. I don't know whether you copied a minute ago on our op support setup 2 structural configuration for launch verification. Apparently, we need a not performed option added to one door that was closed out for flight on the first run and stayed that way. I guess I'd like to go ahead and get on that concurrence to go ahead and work this with a D to follow adding a not performed option there.
What door are you talking about?
Stand by 1. CMQC, OTC.
CMQC. Let me see if I can find that again here.
Okay.
Door 40. I'll move door 45.
Okay, that's a structures door, not an MEQ. Okay. PPE, OTC. PPE, go ahead. Yes, Steve, did you copy, we need a not performed option added on putting the 45 door on this time? That's holding up our verification of the structural configuration on support setup 2.
Okay, yeah, we'll take that action. We'll write the B for you.
Thank you, sir. And CMQC has the details there.
OTC, ECL.
Go ahead, ECL.
I can give you step 697. Final cabin leak check is complete.
Copy that, ECL.
And for step 698, report a TPDT of 0.004.
Copy 0.004.
And we're ready for cabin vent 699.
Okay, copy that, sir. CDR, OTC.
CDR, go.
Yes, sir. We'll want to go ahead and work our cabin vent, and you may get klaxon and master alarm, and if so, reset. And on L2.
CDR, we'll go.
Okay, L2A1.
On there.
Okay, vent isolation switch. Open until vent isolation talkback open.
open the vent ISO until it's open. Okay, we've reset the clock up.
Copy that. OBCC, this OTC. Copy that, sir. Okay, and ECL 702.
ECL verified.
Copy. CDR, verify cabin pressure decreasing.
Cabin pressure is decreasing.
Copy. And CDR, let me know when you show open.
Okay, sorry, we've got open talkbacks on both the vent ISO and the vent, and the cabin pressure is decreasing as expected.
Okay, copy that, sir. Thank you. ECL, OTC.
ECL.
Okay, stand by to give pro words closed cabin vents on channel 212. If a decrease in PPO2 below baseline is observed on CRT page B.
ECL copy.
CGLS, OTC. CCSE, OTC.
CCSC.
Okay, need you over on 232 for S-band and RCRE, OTC.
RCRE.
Need you over on 232, sir.
Copy.
OTC, CDPS.
Go ahead.
683 and 684 complete.
Copy that. DPS, OTC.
DPS, go ahead.
Yes, sir. Step 690, your launch countdown sequence program by the clock at 44 minutes.
Okay.
This is Shuttle Launch Control at T-minus 44 minutes, 40 seconds, and counting.
You have a go.
The range safety officer has begun a final network verification test of the range safety command network. The terminal count range safety closed loop check begins at the T-minus 45 minute point.
Copy that. Thank you.
We've just heard the launch team talking to the Merritt Island tracking station. They are going through the high-powered reconfiguration of their antenna systems. However, they actually won't be going to high power until the T-minus 11 minute point in the countdown. The reason for that is that we discovered during the first count on the Magellan mission last Friday that when the Mila tracking station transmitter is turned to high power, that the receiver on board the Magellan spacecraft is saturated and locks up. In order to prevent that from happening earlier in the count, Mila will not be switched to its higher power mode until the T-minus 11 minute point. If it causes a problem, actually the saturation of that receiver is not a problem once it gets into orbit at all. The Magellan spacecraft actually is capable of a great deal of self-monitoring and fixing of problems by itself. In the rare cases where it is not able to fix a problem, it puts itself into a sleep mode while the ground controllers think about what that problem is and then wake it up and tell it what it needs to do next.
OTC, CMQC.
Go ahead, sir.
Okay, ops port setup 2 is complete.
In the range safety closed loop check, which is presently underway, the test will verify that the shuttle's range safety receiver responds correctly to commands sent from the ground support equipment located in the mobile launch platform using the actual flight codes. Inhibits are placed in the system to prevent inadvertent firing of the range safety devices during this particular test. The ground launch sequencer mainline computer program has been activated and now is actually processing data. This program will monitor various key commands and systems prior to its assuming control of the countdown at the T-minus 9-minute mark. Everything continues to look favorable for an on-time launch of STS-30 at 1:48. We are continuing, of course, to monitor the weather. We have had a violation of the crosswind constraints at the shuttle landing facility, but are not expecting that will be a problem at the time of launch. It is just slightly over the limit, crosswind of 14 knots. The 14 knots is a problem only when it's a direct crosswind. When it's a crosswind component because of a higher level in the wind coming down the runway from the nose, then 14 can be acceptable under some conditions. We're coming up on the 40-minute point in our countdown. The leak checks of the cabin have been completed, and Commander Dave Walker has opened the cabin vents to bring the pressure back to its normal level. During the time that the pressure check is completed, air is vented at a high rate into the cargo bay, and a redundancy check is done to ensure that not only is there a single valve that is protecting the cabin, but also a redundant valve or a backup valve. The countdown clock at T-minus 40 minutes and counting. This is Shuttle Launch Control.
RF SEP source verification. I copy. LTC PPE 212. Go ahead, PPE. Yeah, request CPROP and CMPS to 161, please.
CPROP, CMPS, OTC. CMPS, OTC.
Thank you. This is CMPL to CMPS. They're going over to 161.
Copy, thank you.
OTC CPVD 212.
Go ahead, PVD.
We're going to request permission to reposition vent doors 1 and 2 right-hand side. That'll be step 787 if the white room is clear.
White room is clear, sir.
Okay. And if we have you go, we'll put that step in work.
Okay, you have a go on 787.
And you can, will you please notify AFM that they may see a forward MCA ops indicator change?
Okay, AFM, OTC.
Yeah, CAFM copies.
Okay.
OTC ECL.
Go ahead, ACL.
Cabin venting is complete. We're ready for a cabin pressure reading. Step 770.
Copy that. CDR, OTC, air to ground 1.
CDR is with you.
Could you give us cabin pressure readings?
Cabin pressure looks like about 14.9 to us.
Okay, ECL, you copy?
ECL copies, and we record 14.66 for step 772.
Copy. And CDR on CRT3, what is your cabin pressure show?
Well, you're not going to get a good number there because we haven't got the BFS up yet, OTC. When we get the BFS, we'll have the right display.
Copy that. Yeah, we do have to have BFS. We'll wait on that.
CPVD.
Go ahead.
All vent doors are in normal purge configuration per step 789.
I copy.
OTC CMQC.
Go ahead.
Yes, sir. Step 16, 1027, line item 71 has been waived.
Copy. CDR, OTC, air to ground 1.
CDR, go.
Sir, go ahead and give you a go to perform your pass CFS transfer prep.
This is Shuttle Launch Control at T-minus 35 minutes and counting. In just a couple of minutes, Commander Dave Walker will perform the test of the transfer capability between the primary ascent computer redundant set and the single backup flight system computer. There's 5 computers on board the shuttle, and 4 of them act as what's called the redundant set, or the 4 running together which back up each other, and then a single computer is used as the backup flight computer. This test verifies that critical guidance data can be transferred from the redundant set to the single backup computer, and that the computers can operate in a synchronized manner. Throughout the countdown, the computers talk back and forth to each other, assuring each other that everything is working properly and that they all agree with each other. This test is to ensure that in the remote possibility that the 4 primary computers shut down during ascent, that the single backup computer could take over and the flight could continue safely. The countdown clock continuing at T-minus 33 minutes, 52 seconds and counting. This is Shuttle Launch Control.
TPE, OTC.
TPE, go ahead.
Yes, sir. Did we get that op support setup 2 taken care of?
That's firm. It's written and see, it's in the signature loop.
Okay, copy that.
OTC, TPE.
Go ahead.
Could we have a D runner?
CMQC, OTC.
CMQC.
Yeah, we need a D runner out to the integration console.
We'll get one.
OTC, CDR.
Go ahead.
Okay, I want to put the SL up on the VFS long enough to check that cabin pressure reading you all wanted, and then I'll return it to its present config.
Okay, copy that.
OTC, CCME.
Go ahead.
Okay, BSI read, step 718 is complete.
Copy.
OTC, CMQC.
Go ahead.
Yes, sir. We've called for the D runner, and they should be there within a few.
Okay, copy that.
OTC, CDR, we've put the VFS back in GNC memory, and we'd like to clear the message line on the pass.
Okay, copy that. DPS?
Yeah, DPS copies. Go ahead and clear the message line.
Okay, go CDR.
That's complete.
And CDR, OTC, air to ground 1.
CDR, go.
Okay, we'll want to go ahead and perform our own GN2 press next.
I'm ready.
Okay, on panel C3.
On there.
Ohms engine, left and right switches, arm, slash, press.
Okay, that's complete.
This is Shuttle Launch Control at T-minus 30 minutes and counting. We're just a little less than an hour away from the opening of the window at 1:48 p.m. Eastern Daylight Time this afternoon. We're in the process of having a weather briefing to the launch director. The weather patterns have changed during the past hour, and we'll be standing by to hear the results of that. The orbiter maneuvering system gaseous nitrogen tanks have been pressurized for launch now. Gaseous nitrogen is used to operate the valves, allowing the hypergolic propellants to flow into the engines. That system will now be ready when the onboard computers command the orbital maneuvering system engines to fire for the first time to put Atlantis into its initial orbit. The NASA test director has asked the post-launch inspection and safing teams to report to the assembly area at roadblock A11. These people will be ready for the launch to occur and will move out to the pad at the right time to make sure that everything is safe on the pad. We have 2 build-in holds remaining in our countdown today, both 10 minutes build-in holds, one at the T-minus 20-minute point and the other at the T-minus 9-minute point. We'll stand by for the results of the weather briefing. The countdown clock continuing at T-minus 28 minutes, 17 seconds and counting. This is Shuttle Launch Control.
ISL, OTC. ISL. You ready for 748? Affirmative. Copy. APD, OTC. Go ahead, OTC. Yeah, step 749, check Meg, pre-flight bite. All right, OTC, APD, give you step 750, a successful pre-flight bite. And we'll take not performed on steps 752, 753, and 754. Copy that. OTC, COSC 212. Go ahead. Yes, step 725 through 729 are complete. Step 730, CNC SCARS paraplotter setup is complete at this time. Copy that, thank you. CDR, OTC, air to ground 1. CDR, go. Okay, sir. Stand by to perform SIMO air to ground voice check. CDR, welcome. And CDR, OTC. OTC, CDR. Yes, sir. I might have to break in the middle of your SIMOs at 22 minutes to get you to do that BFS memory display. And I'll give you a break if I do. Okay, I'm prepared. Copy.
This is Shuttle Launch Control at T-minus 25 minutes and counting. The pre-flight test of Atlantis' main Master Events Controller has been completed. The Master Events Controllers relay commands from the orbiter's computers to fire explosive charges to separate the tank and the twin booster rockets from the orbiter in flight. We've just completed the weather briefing to the launch director, and it appears that it's just too close to call at the present time. We are in violation of the ceiling constraint on return to launch site abort at the moment. However, it's expected that within the next hour that it is going to be satisfactory. We're right on the edge now of the constraint as far as crosswinds are concerned. However, that is also expected to change. So basically, we're going to keep going down to the T-minus 9-minute hold, and then we will reassess the weather. The chief of the astronaut office, Dan Brandenstein, is flying in the shuttle training aircraft, and he has perhaps the best view of all and probably the last say as far as the return to launch site abort weather is concerned. The primary criteria has to do with being able to make a safe landing, and one of those considerations, of course, is visibility, being able to see during the time that you're trying to land the orbiter, and the crosswinds, of course, are another consideration. But the shuttle training aircraft simulates exactly what the orbiter is doing, and so a pilot's eye view sometimes is the deciding factor in whether or not we go or don't go. The NASA test director is about to verify to safety that the closeout crew rescue locker equipment has been replaced and the locker secured. The White Room personnel have secured the White Room, and they actually have reached the pad surface and positioned the elevators with their power off and doors closed. And they're moving back to the roadblock in their launch positions. We have just a little over 2 minutes remaining before we go into this 10-minute build-in hold at the T-minus 20-minute point. The countdown clock at T-minus 22 minutes, 13 seconds and counting. This is Shuttle Launch Control.
212.
on CRT3, the DFS member display, doing item 25, show no bugs.
Houston, Atlantis.
Atlantis, Houston, go ahead.
Atlantis, I need to do that item 25 again.
Break, OTC to CDPS.
Go ahead.
He just needs to verify there is no bug by an item 5. He does not have to enter an item 25.
Okay, you do not have to enter an item 25, just verify no bug, sir.
Well, I did it, and there is a bug now.
Okay, DPS, OTC.
Okay, stand by, OTC.
OTC, CGLSN 212.
Go ahead.
Yes, sir. We are reporting an excessive time taken on one-shot data transfer.
This is Shuttle Launch Control. The countdown clock is just about 25 seconds away from entering our 10-minute build-in hold at the T-minus 20-minute point. Everything
Go ahead.
has been working along either ahead of time or on time in the countdown today, and we are right up to date with all of our tasks.
Go ahead.
And we're at T-minus 20 minutes and holding. This is the first of two 10-minute build-in holds which remain in our countdown as we work towards a possible liftoff time at 1:48 this afternoon. We do have a 64-minute launch window, so we have a lot more flexibility today as far as discussing any problems or fixing anything or waiting for the weather as the case seems more likely. At this point, the weather is the main concern. During this 10-minute build-in hold, all of the computers in the firing room or control room are configured with the proper programs for the final portion of the program, of countdown. When we come out of the hold, Atlantis' onboard computers will transition into the Ops 1 configuration, which is the terminal countdown configuration. Also during this hold, the orbiter's inertial measurement units will complete their pre-flight alignment and will go into their inertial mode. Biases or corrections to account for the Earth's rotation between now and launch time will be factored into the navigation units until T-minus 12 seconds, when those constraints are removed and the IMUs go full inertial.
Okay, Frank, we got it all.
Roger that.
Everything proceeding smoothly with the launch team. Everyone in place. At this point, no one may no longer leave the firing room or return to the firing room and must remain seated at their consoles for the balance of the countdown. The countdown clock at T-minus 20 minutes and holding, approximately 9 minutes remaining in this build-in hold. This is Shuttle Launch Control.
CRT3 now, please.
Okay, we're showing 14.5 on the BFS SM System 1, and the meter still looks like about 14.9 to us.
Okay, copy that. Okay, and we'll go ahead now, CDR, and close the cabin vent valves.
Okay, that's in work.
Copy. Your vent isolation switch should be closed until vent isolation talkback closed.
Okay, vent ISO is closed, talkback closed, vents closed, talkback closed.
Copy that. Vent switch closed until vent talkback closed.
That's fine, we got them both.
Okay, and vent valves are closed. ECL?
ECL verify 777.
Copy that. CDFS OTC 212.
Go ahead, OTC.
793.
Okay, sir, I can verify receipt of the flight authorization RAS, and that number is 030.42.
Copy that. RSO NPD 212, contact. NTD.
Go ahead.
Com check on air to ground 1212. How do you copy?
Loud and clear. How many?
Up to you 5 by.
Roger.
HGD, GSS, and JBFX verify active on channel 212 and monitor 232 for remainder of count.
JRPS,
OTC. JBFX.
CGSS verified.
JRPS, OTC 212.
JRPS, go ahead.
Step 805.
Copy. That's complete,
Okay,
OTC.
all personnel on 212, stand by for the T-minus 20-minute briefing at this time. The launch window today opens at 17:48 GMT, closes 18:52 GMT, or a total of 64 minutes. A second launch attempt is possible at this time. There are no known COLAs. If the launch cannot be accomplished within the launch window, or if the following times are exceeded, the NTD will call cutoff. APU runtime is 5 minutes of hold time today, and the vent door will determine at -9. If the T0 wind speed is forecast to be greater than 18 knots, any hold request between T-minus 5 minutes and T-minus 1 minute and 57 seconds will result in a manual hold at T-minus 1 minute and 57 seconds. If a hold is requested and issued between T-minus 9 minutes and T-minus 31 seconds, the countdown clock will be restarted upon a successful resolution of the problem without a go survey made of all elements except for IUS. If cumulative hold times exceed 10 minutes, IUS requires a mark at T-minus 2 minutes prior to pickup account to allow COS to uplink a navigational system reset command. TLT.
TLT, go.
At T-minus 5 minutes, perform APU start upon command of OTC only.
TLT will go.
And CDR?
CDR, go.
The pad egress system is normal at this time. The evacuation pad is 8.
CDR, roger.
Firing room launch team disable telephone ringers at this time. All personnel not active in terminal count will monitor channel 217, and all personnel should bear in mind that critical post-launch operations will be in progress after a successful launch, so firing room activities and noise levels should be to a minimum. Okay, what we plan today is we will count down to T-minus...
This is Shuttle Launch Control at T-minus 20 minutes and holding, just slightly less than 3 minutes remaining in this 10-minute build-in hold. All of the systems engineers have reported back to their respective test conductors that the proper programs are running in their consoles and that their systems are operating properly. The Landing and Recovery Director, Chuck Henschel, has verified that the landing convoy at KSC is ready to support the launch, along with the teams at all of the possible landing sites. NASA Test Director Ron Phelps started his briefing to the launch team a couple of minutes ago on recycle options during the remainder of the countdown. From now until 31 seconds, any of the console operators can ask that the countdown be held if a problem is identified. After 31 seconds, however, any unplanned hold would result in an automatic cutoff of the countdown and a recycle to the T-minus 20-minute point. The launch window opens at 1:48 today and closes at 2:52, a 64-minute window. And he has announced that there are no known COLAs. COLAs are periods during a window when we are not able to launch for one reason or another. The primary reason for COLAs is if there is any chance that the shuttle or another rocket vehicle would come too close to another orbiting body, such as the Russian space station Mir. Today, that's not a constraint. We have about 1 minute and 18 seconds remaining now in this build-in hold.
OFC, AFC, and verified.
When we come out, the Atlantis onboard computers will transition to the terminal countdown configuration, and we'll dump the computer memory of one of the 4 primary computers so that we can look at it and make sure that the Ops 101 or Ops 1 program have been stored properly with no errors. We're about 44 seconds away from picking up the countdown once again at T-minus 20 minutes.
All personnel, the count clock will resume.
The pre-flight alignment of Atlantis' inertial measurement units is complete now.
CPVD 212.
Go ahead.
About 25 seconds away from picking up the count.
Do we want to reduce the payload bay flow rate per the clock, or shall we wait?
We'll wait, sir.
About 15 seconds away from picking up the clock. Everything having gone very smoothly in the countdown for this afternoon's launch.
Countdown clock will resume on my mark.
5 seconds.
4, 3, 2, 1.
T-minus 20 minutes and counting. The purge of the 3 fuel cells is underway to clean the plates of hydrogen molecules which want to stick there and decrease the efficiency of the fuel cells. This purging is done by flowing hydrogen at a high rate through the cell. The data processing engineer has confirmed that the onboard computers are in the process of making the transition to the terminal countdown configuration. As we come up on the T-minus 19-minute mark, Commander Dave Walker will place the backup flight computer in the same Ops 1 countdown configuration. About 20 seconds away from the 19-minute point at this moment.
DPS.
Go ahead.
Pass Ops transition is complete. DPS is ready for BFS transition to Ops 101.
Copy, thank you. CDR, OTC, Air Ground 1.
CDR, go.
Go ahead, OTC. Take BFS to Ops 1 per your checklist.
Okay, that's in work, and we'd like to clear the message lines.
Okay, I copy that. DPS?
Yeah, DPS copies. Go ahead.
CEPP, OTC. CEPP, OTC, 212.
T-minus 18 minutes, 30 seconds and counting. Commander Walker has now confirmed the backup computer is in the proper operational mode.
Verify steps 890.
Thank you.
We're coming up on the 18-minute point in our countdown. T-minus 18 minutes and counting. Everything continuing to go well as we move through this period of our count. The countdown clock will halt once again for 10 minutes at the T-minus 9-minute point.
NTD STE 212. Go ahead, STE. Yes, sir. And for OTC, fuel cell adjustment at step 954, we'd like to hold off until we're into the hold. And as soon as we get the weather status, we need to do it 5 minutes before we come out of the hole. I understand.
NTD, CVFS.
Go ahead.
Yes, sir. Ready for BFS uplink per step 921.
Flight, NTD.
This flight go.
Perform step 922.
Wilco.
T-minus 17 minutes and counting. The dumping of the Ops 1 program stored in the memory of one of the 4 redundant general-purpose computers has started. This takes approximately 7 minutes to complete, after which engineers will examine the data for any miscompares. The flight control engineer is in the process of checking critical aerospace driver currents and positions in preparation for hydraulic activation. Hydraulic activation occurs when the auxiliary power units are turned on at the T-minus 5-minute point.
Horizontal set config and work.
Pilot Ron Graby has indicated that the configuration of the cockpit instrument panel displays for launch is in work.
CFCP, OTC, 212. SCP. Yeah, did you copy SDE on...
T-minus 16 minutes and counting. The data processing engineer is reporting that the backup flight system is in synchronization with the primary system, and the
212 BFS uplink's complete.
NTD, copy.
And that they have transmitted their pre-flight uplink load of the backup flight system to Houston. These loads sent from Houston via the Mila tracking station puts the 5th general purpose computer in the proper configuration to watch quantity levels in the reaction control system and the auxiliary power unit tanks and do other housekeeping chores as needed. Also, as part of this uplink, the most current state vector for the tracking and data relay satellites that are in orbit will be placed in the computer. We've just passed the 15-minute point in our countdown, and you'll be hearing that the cross-feed valves between the orbital maneuvering system and the remote control system are being configured for the launch. T-minus 14 minutes, 30 seconds, and counting. The orbiter test conductor asked pilot Ron Graby to read out the quantities of propellants in the reaction control system tanks.
Copy that, PLT, and you can now perform your MPS helium reconfiguration.
The booster test conductor has been asked to start the gaseous nitrogen purge of the aft skirts in the solid rocket boosters. This flow of an inert gas ensures that no explosive or flammable hydrogen gases can accumulate in the aft skirts of the solid rocket boosters prior to ignition. T-minus 13 minutes, 45 seconds, and counting. During the last minute or so, security has reported to the NASA test director that all non-essential personnel have cleared the blast danger area.
CFCP, go ahead. Okay, fuel cell purge is complete at this time. Copy that.
OTC, CWS.
Go ahead.
Steps 933 through 937 are complete.
Copy, PLT, OTC.
OTC, PLT, go.
Yes, sir. Can you report RCS quantities, forward, left, and right, fuel and oxidizer?
Roger, OTC, RCS quantities, forward 72 ox, 68 fuel, left 99 ox, 99 fuel, right 99 ox, 99 fuel.
Copy that, thank you. OTC, EPD. Go ahead, EPD. We're getting some back channel indication they don't want us to do the fuel cell transfer until after you're ready to come out of the hold. Is that true?
T-minus 12 minutes, 28 seconds, and counting. The purge of water from the onboard fuel cells has been completed. Water is a byproduct of the production of electricity by combining hydrogen and oxygen in the fuel cell, and although it is used for drinking water in orbit, it cannot be allowed to build up too far. Normally we transfer to the use of those fuel cells in this period. However, we're going to hold off doing that until we come out of the next hold. The Landing and Recovery Director, Chuck Henschel, is verifying that all contingency support operations are ready for launch and emergency aircraft and personnel are on station.
OTC, CVFS.
Go ahead.
Yes, sir. T-minus 20 minutes. GPC dump is complete.
Copy, thank you.
And OTC, DPS 963.
Having the confirmation that the dump of the general purpose computer has been completed, the memory is being compared with that of a ground-based computer to ensure that there's no unexpected bits of information in it which could cause a problem during flight. Coming up on the 11-minute point in our countdown.
Flight NTD 212 at ground 1.
T-minus 11 minutes and counting. The flow rate of conditioned air being blown through the orbiter's payload bay is reduced at this point to about 170 pounds per minute.
And TLS NTD.
TLS, go.
Okay, when we get into the hold here, we will cancel pending.
Yes, sir, I copy that.
T-minus 10 minutes, 30 seconds and counting. We're just about a minute and a half away from entering our last planned build-in hold in the countdown for the launch of STS-30.
All personnel on 212, when we get into the hold, we will work the steps as though we're coming out on time, getting everybody's go, and then stand by there for a final go from the launch director when the weather clears.
T-minus 10 minutes and counting. Just heard word being passed along from the NASA test director to the rest of the test team that when we go into the 9-minute hold, we will assume we're coming out on time. However, the release of that hold will depend on whether the weather has cleared and that we have no constraints. The only constraint at the moment has to do with the return to launch site abort criteria for weather. 30 seconds away from entering the T-minus 9 hold. The status of the vehicle is go at this time. The onboard computer programs have been examined and verified to be the proper one. All aerosurface and actuators that will steer the vehicle during powered flight are in the proper configuration, and the flight crew has completed their cabin leak checks and communications checks with the launch team and with flight controllers. T-minus 9 minutes and holding. This should be a 10-minute build-in hold, and we would resume the countdown in time for a liftoff at 1:48. As we come out of the hold, the ground launch sequencer takes over control of the vehicle, issuing commands for the final critical tasks and monitoring as many as 1,000 different measurements during the final 9 minutes. All firing room personnel switch to the same communications channel at this point and stay on it through the rest of the countdown.
And we will be in an extended hold at this time.
We've just had an announcement that we will be in an extended hold at this time.
Understand, sir.
The crew being informed about the extended hold and reporting back. We have, at this point, of course it's not known, but we have 8 minutes and 52 seconds remaining in the standard hold.
Do your RTLS update?
Yes, sir, we'll do that. We have that ready. We have no change, so we won't do that. We'll update it again if we need to prior to coming out of the hold.
I understand.
This is Shuttle Launch Control. We're just hearing that at this point, the runway which would be used in case of a return to launch site would continue to be runway 15.
212, we will use an L-minus 16 count to come out of this hold, so we will give you a 7-minute notice prior to picking up the count. ITD, did you copy?
I copy.
And we'll want you to perform your hold for 5 o'clock at L-minus 15 minutes.
Roger, I'll perform it L-minus 15, thank you.
This is Shuttle Launch Control.
Launch director.
Go ahead, sir.
Okay, I plan on giving you a better heads up than that. About 10 minutes before we're ready to come out, we'll give you a call so everybody can get ready for your L-minus 17 call-outs.
I understand. Thank you, sir.
And NTDSC.
That was Launch Director Bob Seek talking to the NASA Test Director Ron Phelps and telling him that he will give a go for coming out of the count or coming out of the hold about 10 minutes prior to the time that we think we can do that. Right at the moment, we are standing by, taking a look at the weather, and then once it's been determined that we think the weather will be satisfactory for launch, then Launch Director Bob Seek will give a go to pick up the countdown clock 10 minutes from that time. One of the reasons for making sure that we have that amount of time before coming out of the hold is that the Magellan spacecraft needs to have about 7 minutes to put itself into the proper configuration to come out of the hold, and they need to do that before the Merritt Island Tracking Station brings up their S-band antenna to full power. When that occurs, the S-band antenna saturates the receivers on board Magellan, and so it becomes more difficult to do the tasks necessary. The NASA test director, Ron Phelps, is going to go through a status check at this point to determine that all of the systems engineers are ready to pick up the count when we get a go to do that.
Understand. TTC? I'm making the checks right now. Understand. LPS?
LPS is ready.
Houston flight? Mila, NTD.
Milo's go.
STM?
SDM is go.
Safety console?
Safety consoles go.
SPE?
STEs go.
Okay, and how about the one constraint 290, IPR 290?
That's end signature and QC.
Okay. CDR?
The crew is go.
All right. LRD?
LRD is go.
SRO?
SRO, go to resume, but pending the final cleared launch a bit later.
Understand. NTD, PTC? Go ahead, PTC.
Payload to go, pending final issuance of the flight ready command.
Understand.
This is Shuttle Launch Control. As we go through the status check by NASA Test Director Ron Phelps, you continue to hear people saying that they are ready to go pending the completion of certain work. The Magellan spacecraft people saying that they are a go, but that they need to have that 7-minute warning in order to perform their tasks. The Mila tracking station, of course, will need to have warning too. They'll be bringing up their S-band antenna at about 11 minutes prior to the actual...
ready to proceed with the exception of the items that we'll pick up when we start to count at L-minus 60.
Copy that, and I'll go ahead and run my poll at this time.
Payload operations.
Okay, he's off on another channel. We'll come back. Safety and Quality Director.
Launch Director Bob Seek going through an early poll of his people to make sure that they know of no other constraints for coming out.
Director. Confirm no constraints to picking up.
All right, we polled the technical community, and you have our consensus to proceed with this launch. Good luck and Godspeed.
Copy. Cape weather.
Roger, Launch Director, we do have a violation with regard to the ceiling less than 8,000 feet, and otherwise our prevailing winds at launch be from 110 degrees at 12 knots.
Okay, copy. And for this count, since we have a limited APU budget going in, we're going to set 5 minutes into the whole clock for after APU starts, but we can amend that in real time if it looks like we're converging on whatever problem may have caused us to go into a hold after that. So we'll set 5 minutes to the clock, although we do have more based on prevailing winds.
This is Shuttle Launch Control. Launch Director Bob Seek checking with the various managers to assure that they are ready to go. He was talking about the fact that there's a limited amount of reactants that are used for the auxiliary power units, and that at the present time we're assuming that we have 5 minutes of hold time after we start those auxiliary power units at the T-minus 5 minute point. But we're going to have at least 10 minutes notice before we pick up the count, and the primary constraint is we have clouds in violation of the 8,000-foot ceiling out at the shuttle landing site. The launch of STS-30 and the Magellan spacecraft raises the question in some people's minds of why do we want to go to Venus in the first place? Venus is the most Earth-like planet in the solar system, but as far as Earth-type life, it is in big trouble. Ground temperatures of 800 degrees, mostly carbon dioxide in the atmosphere, sulfuric acid in the clouds, and an atmospheric pressure on the surface 90 times that of Earth is not good for people. Scientists have already learned lessons which may help preserve human life on Earth, and they hope to learn a great deal more. Venus may have a case of terminal greenhouse effect, which people could induce on Earth if they were not more careful. And that's one of the reasons for studying the planet so closely. Venus was the first of the planets in the solar system to have spacecraft directed towards it, going back to about 1962. Since that time, there have been 20 spacecraft sent to the planet, and this one will return more information than has ever been returned before. Magellan is a very smart spacecraft which can heal itself of many problems, and if it decides it cannot fix something, it puts itself to sleep temporarily to allow controllers on the ground to work out the problem. There are two other major experiments on board the STS-30 mission. One is a microgravity research with a fluids experiment apparatus built by Rockwell, and is part of a joint research program between Rockwell and NASA. The program is designed to look into such things as crystal growth experiments, which is on here, but also optical glass research, monodispersed latex reactor, and other areas. It began in about the 1980 time frame, and the device has been flown on STS-14 and 41D. In this particular experiment, a piece of metallic material will have a small seed crystal attached to it, and then in the near zero gravity atmosphere of the orbiter, it will be melted, and the seed crystal will cause the metal to crystallize as a monolithic crystal. And as the heater moves away, the elements in the material take on the same structure as the seed crystal, and the few impurities that might be in it move down along that place where the melting is occurring and accumulate at the end, resulting in a large and much purer crystal than can be grown here on Earth. Another major experiment is called the mesoscale lightning experiment, and this takes advantage of the onboard cameras on the orbiter to do some research of the type needed for the design of satellites which will be looking at lightning in the future. It turns out that the angle that is seen by the payload video cameras on board the orbiter is about the same view of Earth that is seen by the sensors which are being designed to look at lightning. Mesoscale lightning really is lightning over a very large area of the Earth's surface, and that type of lightning, which may go hundreds of miles in any one direction or in several directions, cannot be observed presently from the Earth or from aircraft. The type of storms which produce mesoscale lightning actually produce about 40% of all of the rainfall over the entire United States. The launch team here in the firing room and the crew, the flight crew out on the pad, being very quiet here as we stand by to see whether the weather will change sufficiently. We've seen some evidence of movements of the clouds, and we are standing by to see if the cloud cover will move out there at the shuttle landing facility. Dan Brandenstein, the chief of the astronaut office, flying in the shuttle training aircraft, and will probably be the first to say that he is able to see the runway sufficiently for a launch, if that should be the case. Once we have an indication that we may be able to go, Bob Seek, launch director, will give a 10-minute warning so that the launch team and particularly the payload people can plan their activities, which they need to go through prior to coming out of the hold at T-minus 9 minutes. Everything in readiness, no known problems other than the weather at this time. We are still at T-minus 9 minutes and holding.
CDR, NPD, air to ground 1.
CDR, go.
Okay, just wanted to verify you guys haven't gone anywhere. We're still here, and they're still looking at the weather.
Yeah, we thought we'd stick around, see how it turned out.
Well, hopefully you won't have to wait too long.
Yes, launch director, we're always glad to have you aboard, Dave. I think we're getting this part of the countdown real good. We just need to work on the last 9 minutes in the weather.
Well, y'all have done a great job. It's not in your hands now, but crew appreciates the efforts. And now if we can just make the weather work, we'll go fly.
Roger that.
This is Shuttle Launch Control. NASA Test Director Ron Phelps letting the crew know that everybody's still alive and well in the Launch Control Center, and the crew indicating that they plan to stick around to see how this all comes out. And then NASA Launch Director Bob Seek talking to the crew as well. The launch of a shuttle is a real team effort, which requires the work of thousands of people just here at the Kennedy Space Center. That team becomes very close-knit during the time that the preparations are going on, everybody relying upon each other to perform their job in a very complex mission. One of the interesting aspects of the Magellan mission is that Magellan has sacrificed speed to assist the Galileo program. If Magellan could be launched at the proper time in the Earth and Venus orbital relationship, the spacecraft would be able to zip over to Venus in just 4 months. By giving up the best time for the trip, the Magellan scientists allowed the Galileo scientists to have the best launch period. As it is, Magellan will take about 15 months to get to Venus, but Galileo, which is actually going to Jupiter, will take 4 months to go to Venus, and then making use of the gravity of Venus, will use that mass as a slingshot to add energy and speed to its journey and fling it outward towards Jupiter. Finding another opportunity to launch the 2 spacecraft towards Venus this year took all the ingenuity of the mathematicians and physicists who designed the roadways through the solar system. Following its launch from the shuttle and its start on its way to Venus, the Magellan spacecraft actually will pass through the orbit of Venus at a time when Venus is not at that point. It will then swing on an orbital path around the Sun, come back and intersect the orbit of Venus when Venus is there. It will come in over the North Pole of Venus and be placed in an elliptical orbit that will range from about 155 miles above the surface to 4,977 miles from the surface. During the period when it is closest to the surface, it will do its radar mapping, and during the period when it's furthest from the surface, it will be sending those signals back to Earth. Actually, it can be gathering information faster than it can be sending it back, and so about 1/3 of the orbit will be devoted to gathering information and 2/3 to sending it back. Everything very quiet here on the various circuits in the Launch Control Center as we stand by to hear more from the weather, which will be the deciding factor on the launch for today. We have 54 minutes and 14 minutes remaining in our window, and that counts the time that's necessary to come out of the hold and pick up the count once again. The countdown clock holding at 9 minutes, 4 clouds over the shuttle landing facility. This is Shuttle Launch Control at T-minus 9 minutes and holding. Launch Director Bob Seek talking to Mission Manager Bob Crippen. Giving an alert to the launch team that we will probably pick up the countdown at L-20. L-20 actually means that it's 20 minutes before the actual launch time. What will be done is, in order to preserve every bit of the window that's possible, we will do the payload preparations. We will start the fuel cell load sharing. We will count down to the T-minus 5 minute point and hold prior to turning on the auxiliary power units. The auxiliary power units are one of the constraints to holding any later in the countdown. There's only about enough reactants to hold for 5 minutes or so. The window is a 64-minute window, and of course it opened at 1:48 and goes to 2:52. The launch director is talking about a plan which would enable us to hold at the 5-minute point in our countdown and therefore make as much use of that window as possible. As it is now, if we were to come out of this hold, it would take us about 20 minutes to actually get to launch. With a window that is only 64 minutes long, that means that it's important that you not wait until about 15 minutes before the end of the window because you don't have enough time then to make use of that entire window. As it is, we're standing by here waiting for further word on the weather. The only violation has to do with the cloud ceilings at the shuttle landing facility, which do not offer enough visibility for a landing should the orbiter have to come back to the Kennedy Space Center after launch. Launch Director Bob Seek will be discussing the plan further and setting a time for picking up the count and proceeding further just a few minutes from now. This is Shuttle Launch Control. Conversation going on by the team, Launch Director Bob Seek, Mission Manager Bob Crippen, the flight controller in Houston, about a plan which would bring us out of the hold and then count down to the T-minus 5 minute point. The Launch Director Bob Seek will announce that to the team as soon as he's ready as to what the plan will be in order to preserve the maximum amount of our launch window today in hopes that that cloud layer will lift. We continue to hold at the T-minus 9 minute point, and at the time we start the preparations.
SRO on OIS 212.
Go ahead, SRO.
Roger, the ceilings we have, the low ceiling conditions make us no-go at the moment for range safety because of lack of optical coverage.
However, we are working to reconfigure some of the long-range tracking cameras so that we feel that we can overcome that situation. I'll let you know the status of that.
I understand. And MTD, this launch director.
Go ahead.
Okay, as we wait on the weather here, in order to be in a posture to get this thing off with short notice, if it ends up that way, I would like to be in a posture to be at L-minus 20 minutes and counting at 18:15 GMT time. And at that point, go on down to -5 minutes. If we get the concurrences before then that the weather is cleared and the ranges go, we'll just press right on through the -5 minute point. If we're not, we will stop and hold there until we can wait for the weather to clear and get to go. If we do hold there, Houston will need a couple of minutes prior to coming out of that hold to reconfigure their recorders. But again, I'd like to be ready to pick up in just about 15 minutes at 18:15 GMT.
Okay.
And that'll be L-minus 20 for the benefit of the team.
This is Shuttle Launch Control. Launch Director Bob Seek announcing to the team that we will pick up the preparations for the launch of STS-30 and Magellan at 18:15 Zulu. That's 18:15 Greenwich Mean Time, which equates to 2:15 Eastern Daylight Time. At that point, actually, you won't see the countdown clock start moving because we're going to be at what's known as L-minus 20 minutes, which is 20 minutes prior to an expected liftoff. So we will actually pick up the clock at the T-minus 9 minute point at 26 minutes after 2 with local time. The plan is to continue counting down to the T-minus 5 minute point and then hold there if necessary. The only constraint we have at this point has to do with the weather and with the cloud cover over the shuttle landing facility. The Superintendent of Range Operations also has a constraint that has to do with the amount of coverage he's able to get with his cameras as they watch the shuttle go up through the atmosphere away from the Cape. But we'll stand by to listen to the crew or the team as they begin their preparations to pick up the count once again.
Okay, all personnel on 212. What we see here is we want to be at L-minus 20 minutes at 18:15 GMT would give us a T0 of 18:35. The hold time remaining clock will pick up at minus 11 minutes and counting down to resumption of the hold at 9 at 18:15. And the plan would be to count down through, pick up the count at 9, continue down with a potential hold at minus 5 minutes prior to starting the APUs. And personnel should be advised that from L-minus 5 minutes, we will not necessarily give you any kind of long-term count as far as picking up there goes, which says PTC, we may or may not be able to give you the 2 minutes prior to pick up the count at 5. You copy?
NTDSP 212.
Go ahead, SP.
Yes, sir. Looking ahead, APU pre-start, as long as we can only hold there for 17 minutes, we can go ahead and perform the book as written. Do APU pre-start at 6 minutes.
I copy.
And OTC copies. NTD CGSS.
Go ahead.
If we do hold at 5 minutes, we'll be performing hold option 1 and extending the OAA. We will need a kickoff before if we did that, we would need about a 4-minute kickoff.
No, we'll go ahead and swing the OAA.
will.
Keep it in the, we'll keep it in the retract position at that time.
I copy.
Okay, as far as the OAA goes, it will be retracted and stay retracted for that hold at -5.
This is Shuttle Launch Control at T-9 minutes and holding. The crew has been informed about the plan as well as the launch team in which we begin our preparations to come out of the hold.
We have some port boundary updates to pass to the crew.
Okay, why don't you go ahead and do that now?
We will be picking up the preparations at the point where we're 20 minutes prior to the estimated liftoff at 15 minutes after 2. Actually, the countdown clocks will not actually start at the 9-minute point until 11 minutes later, so the clock would actually start at 18:26, and then we will continue counting down to the T-5 minute point, where the clock will hold unless the weather has improved sufficiently to go ahead. This will enable us to make use of the entire window. The close of the window for this launch is dependent on the lighting conditions overseas at the Ben Guerir, which is the primary transoceanic abort landing site in Morocco, Morón in Spain, and in the Gambia at Banjul. At the present time, the crew being updated on their times and the conditions overseas.
TTC NTD 212. Go ahead, NTD. Good copy. We're going to go ahead with the payload bay purge reduction at this time. Yes, I do. Okay. Go ahead, OTC.
DVD, OTC.
DVD.
Okay, you got to go to perform your reduction.
We're putting step 969 in work now.
Copy that. CFCP, EPD, OTC. EPD here.
This is FCP.
Okay, at 18:15, when we pick back up with the 11 minutes on the clock, you guys can go ahead and pick up on 954, 965, and on. Copy, 8:15 by the clock, 18:15 by the clock? Yeah, 18:15 GMT.
And CFCP copies.
Launch Director, this is Cape Weather on 212. Launch Director, this is Cape Weather on 212.
Roger, Cape Weather, would you go over to 231 for a moment, please?
You're doing this all better.
Do you want me to go to 231, sir?
Does it hurt?
Affirmative, go to 231, Cape Weather.
Still hurts. I had mine done a month ago.
All personnel should check their comm boxes. Only test team personnel direct and launch should be on 212. We have someone cross-channel.
This is Shuttle Launch Control. We're just about 2.5 minutes away from picking up some activity at the L-20 minute point in our countdown. The weather officer talking to Launch Director Bob Seek about the conditions at the shuttle landing facility. It is moving a little bit towards the north, but it's not moving very fast. There is some broken clouds out there at the 8,000-foot level, and Chief of the Astronaut Office, Dan Brandenstein, continuing to take a look from the shuttle training aircraft at those clouds. He reports that there's no precipitation in those clouds, but nevertheless the visibility is the primary consideration. We're a little less than 2 minutes away from picking up the L-20 activities. Actually, the spacecraft people standing by here listening to the weather forecast At the moment, the range is red also because they have violations of constraints which have to do with the optical tracking of the orbiter as it ascends through the atmosphere. During this first part of this period, there will be mostly spacecraft activity going on. At L-minus 16 minutes, they will command the support batteries online. These are the batteries which operate the tilt mechanism that tilts the inertial measurement, or the inertial upper stage, and the Magellan spacecraft up from the horizontal position in the payload bay to put it into a launch configuration from the orbiter. And then they will release their hold, fire, enable at the L-minus 15 minute point. And the largest and the most critical of their activities has to do with the navigation system being placed into its flight mode. And we're coming up, we are now at L-minus 20 minutes and counting. You will not see the countdown clocks if you're watching them move at this point, because L-minus 20 is still within the T-minus 9 minute built-in hold. T stands for time and has to do with the time that the countdown actually is underway, but does not include the time that it's in a hold. L has to do with the number of minutes before the actual liftoff. So we're at L-minus 19 minutes 20 seconds and counting, but we're still at T-minus 9 minutes and holding.
26 resume time.
Yes, sir, that's firm. Yes, ma'am.
OTC EPD. Go. Fuel cell load sharing transfer is complete. Copy. OTC, CATD. Go ahead. HCDS prime and backup units are updated.
Launch Director Bob Seek asking that another poll be made of the readiness of the various systems engineers in about 5 minutes from now, looking toward the release of the hold clock at the T-minus 9 minute point. We are at this point, though, we will only be counting down to the T-minus 5 minute point and then holding there to put us into a posture to take maximum advantage of the window that we have for today's launch. It's a 64-minute window, and it closes at 2:52 p.m. Eastern Daylight Time.
CPVD 212.
Go ahead.
Step 969 is complete, and 970 and 971 are not performed, as well as 972.
Copy that. Thank you.
This is Shuttle Launch Control. The countdown is underway now for picking up the countdown clock at the T-minus 9 minute point. We still have several constraints to launch today. The Superintendent of Range Operations still shows that the range is red because of the necessity for greater optical coverage of the launch, going through the very beginning now of our readiness poll.
And let them run, or do we need to not start them?
We'll start the recorders in time to let them pass the GLS checks, and then if we hold at -5, we'll stop them till we pick up again.
Okay, and be advised, we may not be able to give you much time there at -5.
Understand.
Okay. ISL? This is ISL, I copy that. Okay, do you concur? I concur. Okay, COEX?
OEX.
Okay, does that give you a problem?
Negative.
Okay, and JRPS?
This is JRPS, no problem.
Okay, what we'll plan on do, we'll start them at L-15, and then if we need to secure them at 5, we'll do that, and then restart them with no further go from me.
I'm just going to leave my ground recorders running because I've got plenty of tape.
I understand. C-Power, TVC.
This is C-Power.
Okay, before the SRB DFI power application.
Copy. In work.
This is Shuttle Launch Control. Very quiet here as the team carefully moves through the work necessary to bring the launch vehicle back into a state of readiness to pick up the count once again at the T-minus 9-minute point.
4, 3, 2, 1, mark. Flight IFL, OEX, JR.
We're standing by for completion of some of those readiness polls. Expect to hear from Launch Director Bob Seek and Mission Operations Manager Bob Crippen shortly.
NTD Launch Director.
Go ahead.
Okay, I want to make a couple of final polls here. Payload operations. Payload operations are go, Bob. I copy. And operations manager, launch director.
Okay, Launch Director, Ops Manager, your go to continue the count with the restriction on the RTLS weather. We'll work that as it comes through.
I copy, and we'll hold at T-minus 5 minutes if we're still no-go on the RTLS conditions.
Roger.
Okay, and NTD Launch Director.
Go ahead, sir.
Okay, so you have a go to pick up at 9 minutes on your count with the proviso that we will hold at T-minus 5 until we get a final go on the RTLS conditions.
I understand. And GLS, will you hold us at 5? CGLS?
Yes, sir, go ahead.
Okay, would you program a hold at 5? And
We
be
won't plug that
prepared to
in.
hold it?
Yes, sir, we'll plug that in when we get a little closer.
Okay.
This is Shuttle Launch Control. We have completed our readiness poll, and except for the weather problems, we are ready to come out of this T-minus 9-minute hold exactly
1, mark, 4 minutes away.
4 minutes away from picking up the count at the T-minus 9-minute point. However, the clock has been programmed to stop at T-minus 5 minutes. That can be changed if necessary. The payload people in the process have completed their activities. The primary job to be done is to put the command navigation system into their flight mode. That occurs just 2 minutes before we come out of this hold, about 3 minutes from now.
The count clock will pick up in 3 minutes on my mark. 2, 1, mark.
This is Shuttle Launch Control. Just about 2 minutes 45 seconds away from picking up the clock at the T-minus 9-minute point. You'll hear the recorders and the flight recorders being turned on. Those will be turned off again at the T-minus 5-minute point, and then they will have to be turned on again before we come out of that hold.
ISL 212. Go ahead, ISL. Recorders are activated. Copy. The countdown clock will start in 2 minutes on my mark. 1, mark.
Just 2 minutes away from picking up the count at the T-minus 9-minute point once again. The inertial upper stage being placed in its final launch configuration. Everything satisfactory in the payload world. With the 64-minute window for Magellan and the launch of STS-30, we have until 2:52 this afternoon to launch.
The countdown clock will start in 1 minute on my mark. 5, 4, 3, 2, 1, mark.
1 minute away now from picking up the clock at the T-minus 9-minute point.
Our system is enabled.
Copy.
They're hearing that the crosswinds at the shuttle landing facility not quite as good as we had thought before. They were right at the margin prior to this, but there are some gusts out there now.
NTD, PTC, step 16-1024 is complete.
Little less than 30 seconds away from picking up the countdown once again.
Go ahead, CCSC.
Yes, sir. Per that deviation, step 1022 alpha, mile at 10K. CTSC can verify his frame sync lock. AGC is 85.
Stand by, please.
The countdown clock will start now in 5 seconds. 2, 1, mark, and T-minus 9 minutes and counting. The countdown events now being controlled by the ground launch sequencer from now until T-minus 31 seconds, when we begin the switchover to the onboard redundant set launch sequencer. The ground launch sequencer is part of the launch processing system and operates by relaying commands to the onboard computers, which then report back to the LPS system that the commands have been executed. The primary job of the onboard computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are normal and staying within their prescribed limits.
Thank you.
The Maryland Island tracking station has gone to high power on their S-band antenna. Coming up on the 8-minute point in our countdown. T-minus 8 minutes and counting.
Flight OTC. Houston flight OTC. PLT OTC. OTC PLT go. Configure fuel cell with central bus source switches.
Orbiter test conductor Mike Key has requested that Houston send the stored program commands, which is the final update on antenna management and frequency changes, and he has asked pilot Ron Graby to reconfigure the fuel cells, and we have gone for orbiter access arm retract.
This flight go?
This is the walkway used by the astronauts to enter the orbiter. In case of an emergency, the arm can be placed back into position within about 15 seconds. Coming up on the 7-minute point in our countdown. T-minus 7 minutes and counting. We're going to be stopping and holding the countdown clock at the T-minus 5-minute point prior to turning on the auxiliary power units and stay there in that position until the weather either clears or does not allow us to go today. Coming up on the 6-minute, 30-second point, mark T-minus 6 minutes, 30 seconds and counting. Pilot Ron Graby will be asked to set the switches in the cockpit to the pre-start position for the auxiliary power units, or APUs, at this T-minus 6-minute point. This consists of positioning a number of switches and verifying they're in the proper position, then throwing the 3 propellant isolation valve switches that allow hydrazine to start flowing from the tanks towards the APUs. T-minus 6 minutes and counting.
Copy. PLT OTC. OTC PLT go. Perform APU pre-start. APU pre-start in work.
Pilot Ron Graby reporting APU pre-start is in work. Mission Control has transmitted the signal to start the onboard flight recorders. However, those will be turned off after we stop the countdown clock at the 5-minute point.
OTC PLT. We have
T-minus 5 minutes, 20 seconds and counting. The clock will be holding.
APU pre-start complete. Great talkbacks on 1 and 3. Barbara Paul on 2. Copy that. CH-20.
Pilot Ron Graby reporting APU free start is complete, and we're at T-minus 5 minutes and holding.
Boiler OK is off. Should be on.
At this point, we will continue this hold. We will not start the auxiliary power units until we have confirmation that the weather is satisfactory and that any other constraints to the launch have been cleared.
OTC, copy. NTD, copy.
Countdown clock is holding at T-minus 5 minutes.
We have approximately 21, a little more than 21 minutes remaining in our window today. It started out to be a 64-minute window, and it opened at 1:48. At this point, we still have some constraints. We are just hearing from the weather aircraft, or from the flight operations in Houston, that there appears to be scattering of the clouds near the ends of the runway. This could be good news. What's important is that those clouds get out of there and that they not be blown by winds that are too strong as they come across the runway.
ISL 212. Go ahead, ISL. I was talking to flight on 145, and we're going to let Ops 1 and 2 and the payload recorders to continue to run. We have enough tape on those, and we're putting the MADs into the snapshot mode to conserve tape. I understand. Thank you.
This is Shuttle Launch Control. We're continuing to hold at the T-minus 5 minute point. The mission management team and launch director Bob Seek talking about any other things that we can do in order to preserve as much of the hold as possible. We have actually 18 minutes and 34 seconds remaining in our window. We need 5 minutes of that in order to get the orbiter ready and proceed. We may need a couple of minutes warning in order to restart recorders and to make sure that everything is ready to pick up once again. The first task that will basically occur when we come out of the hold would be the turning on of each of the 3 auxiliary power units. Since there is only about a 5-minute hold time possible once those are on, it's prudent to be sitting in this condition at the T-minus 5 minute point. The Magellan payload sitting in the cargo bay just as the crew are in the cabin, wondering whether this is the day that it starts on its journey. This is Shuttle Launch Control, T-minus 5 minutes and holding. We can stay in this posture approximately another 11 minutes and 30 seconds, and then we would have to pick up the count if we were going to make the end of the window. We have not had any indication from the weather people recently that there is a big change occurring out at the shuttle landing facility. And we have not heard from the Superintendent of Range Operations whether he is in a go condition at the present time. The shuttle vehicle has done very well as we have gone through this countdown. No problems have been identified at this point, and we are standing by for the weather to clear.
Roger, sir. We are scattered at the SLS. We just got an update observation.
We copy that, and we're looking at the crosswinds now. For the benefit of the team, in order to be ready to pick up the clock in no later than 10 minutes from now, which is what we need to make the window, we would like to, in about 5 minutes, start activating the recorders and the other items that we would have to clean up before we'd be at 5 minutes and counting in the event we get a go. Copy.
This is Shuttle Launch Control at T-minus 5 minutes and holding. We're hearing the weather forecaster say that the clouds are broken. This is Shuttle Launch Control. The flight director at Houston talking to the shuttle landing facility and the weather people here. They have heard word that the clouds at the shuttle landing facility may be scattered rather than broken at this point. We continue to look at satellite pictures and have observers. We are hearing that the clouds at the 1,500 foot level on the landing facility are scattered at present. This is Shuttle Launch Control, T-minus 5 minutes and holding. We're standing by for a weather update. This is Shuttle Launch Control. We are hearing that the weather at the shuttle landing facility is improving. At the present time, we are standing by to hear whether or not we can release the hold and proceed on. This is Shuttle Launch Control at T-minus 5 minutes and holding. We're continuing to hear discussion of the wind direction, the clouds condition. We apparently have scattered clouds for the approach to the 1-5 end of the runway, which is the preferred way because of a tailwind if you come on the 3-3 direction.
Okay, you're going to bring your APU and hydraulic strip charts up. Affirmative, whenever you give a go for APU start. Copy.
Launch Director, NTD.
NTD flight on 212.
Go ahead, fly.
Yes, sir, we're go for launch. We're ready to pick up the count.
Okay, and SRO?
This is the SRO. Stand by, please.
This is Shuttle Launch Control at T-minus 5 minutes and holding. We have had a release from weather, and we are go for weather. We're standing by to hear from the launch director.
Management team and launch director also. Okay. GLS, NTD.
Let's go.
Okay, let's pick up the count on your mark immediately.
I copy. 3, 2, 1. Mark.
And we're T-minus 5 minutes and counting. Ron Graby has been asked to go for APU start. He has flipped the 3 switches in the cockpit to start 3 of the 3 APUs.
Copy that. SRO, NTD. SRO, NTD.
NTD, SRO, stand by. I'm trying to get the final clear to launch.
CDR,
The liquid oxygen replenishing of the LOX tank has been terminated. At this point, the liquid oxygen fill and drain valve is closed. T-minus 4 minutes, 22 seconds and counting. The SRB and external tank safe and arm devices have been armed.
NTD, SRO on 212.
Go ahead.
Final clear to launch from the range.
I copy, thank you.
A final clear to launch from the Superintendent of Rain Operations as we come up T-minus 4 minutes and counting. The main engine final purge sequence is underway. The orbiter flight control surfaces, such as elevon, speed brakes, and rudders, now being moved through a pre-programmed pattern to verify that they are ready for launch. T-minus 3 minutes, 40 seconds and counting. T-minus 3 minutes, 30 seconds. All 3 engines now being moved through a pattern to verify their readiness for ascent flight control. After going through their paces, they'll be aligned to their start position. T-minus 3 minutes, 18 seconds and counting. We're coming up on the 3-minute part in the countdown. At T-minus 2 minutes and 55 seconds, the start of external tank liquid oxygen pressurization will begin and the gaseous nitrogen purges of the main engines will be terminated. T-minus 3 minutes and counting.
Let's just go for ET-LO2 pressurization.
The liquid oxygen tank being pressurized. The ground launch sequencer has started to retract the gaseous oxygen vent tube or beanie cap on the external tank. The computers will make a final check to ensure the vent arm is fully retracted at the T-minus 37-second point. T-minus 2 minutes.
No unexpected errors. Copy that, sir.
T-minus 2 minutes, 20 seconds. The pilot, Ron Graby, has cleared the caution and warning memory. The crew will be reminded to close their visors on their launch and entry helmets at the 2-minute point. Just 5 seconds away from that.
OTC to flight crew, close and lock your visors and initiate O2 flow, and have a good flight. And PLT, OTC, turn on debris camera at T-minus 10 seconds.
T-minus 1 minute, 50 seconds and counting. Liquid hydrogen replenish of the external tank has started and pressurization to flight level is underway.
We are ready to fly. Copy that.
Command.
We'll go on the debris camera. Copy that.
Commander Dave Walker saying they're ready to fly. T-minus 1 minute, 30 seconds and counting. At the T-minus 1 minute point, the ground launch sequencer will verify that the shuttle main engines are ready to start. T-minus 1 minute, 20 seconds and counting. The liquid hydrogen tank now at flight pressure. Coming up on the 1 minute point in our countdown. T-minus 1 minute and counting. The sound suppression water system is now armed. Pre-liftoff water will be released at T-minus 16 seconds. T-minus 50 seconds and counting. The hydrogen burn igniters have been armed. They'll burn off any residual hydrogen gas under the main engines. T-minus 40 seconds and counting. The external tank heaters on the ET to orbiter structural attachments have been turned off. Orbiter computers have, and we have gone for auto sequence start. T-minus 26 seconds, 25. T-minus 21 seconds, the SRB nozzle gimbal profile underway. T-minus 15, 14, 13, 12, 11, 10. We have a go for main engine start. 7, 6. We have main engine start. 2, 1, 0, and liftoff. A new era for planetary science begins as Atlantis clears the tower.
Houston, Atlantis, roll program.
Roger, roll, Atlantis.
This is Mission Control. Good roll program confirmed. Standing by for engines to throttle down. All 3 engines will be throttled back to 65% performance as the vehicle passes through the area of maximum dynamic pressure. Three engines now at 65%. Velocity now 1,000 feet per second. Atlantis 2 miles downrange. Engines now throttling back up to 104% performance. Atlantis velocity now 1,500 feet per second.
Atlantis, go at throttle up.
Atlantis, roger, go.
Standing by for separation from the SRBs. Velocity now 2,000 feet per second. Altitude 10 nautical miles. Downrange distance 8 nautical miles. This is Mission Control. All APUs looking good. 3 engines at 104%.